Buongiorno a tutte e a tutti.
Good morning, everyone. It is with great pleasure and that I am to start this most important symposium. We are quite on time according to our agenda. At the beginning, we have some institutional addresses, followed by the official opening of the symposium that is rich with the many reports and presentations that are listed on the agenda. As a result, I would like to ask Dean Professor Stefano Marini to come to the floor and deliver his address. So first of all, thank you for being here with us today. Allow me to greet you on behalf of the rector who cannot be with us because of a previous engagement, but he would like to greet you most sincerely. Today, we know it's a very important day. It's important both for patients as well as for all of the participants because it's an opportunity that we have to meet and talk about the problems of the rather rare pathology, 1 out of 50,000 individuals. So this is a rather rare pathology. So we must be humble, brave, and courageous to meet and try and find solutions together. This is fundamental for patients and for ourselves as well, because we can therefore grow together. We are talking about this incredible day with Dr. Bertoldo Castori, Professor Novelli. That is, we are talking about really outstanding researchers and scientists that will be with us. So thank you to the organizers for gathering people that with their contributions will make us grow. So I will stop here and wish you a most profitable meeting today. So thank you once again. Thank you. Thank you to the Dean for his kind words. And right now, we can start with the official opening of the symposium. I see that Maria Chiara is ready at the podium already. And then we will pass the floor to the chairman of the association. We wish to thank the University Policlinico Tor Vergata for hosting us here today. Following these addresses, I think we should greet you all most warmly, not only the distinguished colleagues that are here with us, but also I wish to greet all of our friends that are here in the hall that I define as friends of the heart and the aorta, that is the patients associations that are always by our side and that are at the core of our training and information activities. At the end of the day, we will thank everyone. But before I forget thanking all of the people concerned, I would like to start by expressing my deepest appreciation to the organizing committee. I'm a member of it, but we have 3 very special members. First of all, Dr. Maria Chiara Tealdo, a round of applause to her. Dr. Maria Chiara Tealdo is the president of the association with Giacomo against the symptoms of the vascular EDS, and ever since I met her, my professional life has changed because she has provided us many inputs to improve such a very rare pathology. But ever since we have been working with the association, we have been more effective. So I also wish to thank Dr. Pietro Lorenzi, still from the same association that I just mentioned. And I believe that I should also mention a very special person, a distinguished professional, Dr. Castori, who's here by my side. These three people have sponsored, financed, and very well organized this symposium. And if we're here today to talk about the vascular EDS in a very special month, because May is the month dedicated to the awareness about the vascular EDS. And this is the the type 4 vascular EDS day. So I would like to thank Forcy Lab and the team of it, and I think we should really show them our appreciation. We also wish to thank Dr. Isabella Mastrobuono and Professor Marini for hosting us here at the conference hall in the Policlinico Tor Vergata. Once again, I'd like to renew our thanks to the Dean and to the Rector from the University Tor Vergata, and also the Telethon Foundation that has granted its edges to our event. Now I'm done with my appreciations, and let me just summarize what is to be expected. We will be talking about hereditary arthropathies, and we will talk with Professor Novelli, first of all, and we will pay special attention to the type 4 vascular EDS. We will try and understand how to make it faster and more rapid, the diagnosis, and also how to plan a diagnostic and care process so to have the best management possible of our patients. This path must be shared at the regional level, but not only, I would say also at the national level. So today we should try and understand how to improve the pre-treatment phase, which is the prevention phase, and also the therapeutical phase that could be pharmacological or surgical. Then we will focus on the basic role played by the associations and the Telethon foundations for fundraising, because these are key allies, because our reference centers need the closeness of the associations and the patients as a whole. We have changed our paradigm. We have gone from a patient-centered approach to an approach that sees the patient as a part of the team, obviously with many difficulties related to different issues, privacy included, but the patient now has become an integral part of the multidisciplinary team, and that is of the essence because despite our experience and background, we need the patient's approach and view. We will then go on and conclude the conference with a very important session dedicated to research. And we must understand that without research, we have no future. And this has to be a 360-degree research, meaning that it has to embrace genetic that will lead us to genetic therapies, but also it will go from this to innovation. So databases, IT platforms that allow us to share these small data, but that pulling all of the different centers, they become big data. And it's also important to rely on artificial intelligence as one of our supports. Now I have come to the end of the official opening of the symposium, and I would like to pass the floor to Dr. Tealdo. I pride myself in calling her Maria Chiara, who is the president of the ConGiacomo Association, and to her now the floor. Thank you. Thank you, Fabio. Thank you, everyone. Fabio Bertoldo has presented us and also thanked all of the counterparts that I was going to thank. The dean earlier on made a statement that is most important. That is, we are many today, very diverse, depending on our competences and approaches. But today, it's a day of sharing with clinicians, researchers, and certainly we have many partners now logged online, but most of all, we have families that have stayed in contact with us over the years. They are our first link, our first tie in this very difficult path. Pietro and I set up this association known with Giacomo in the summer 2021 when Giacomo was hospitalized many times, also in intensive care for many hemorrhages and also for the perforation of cavus organs. Other presenters will talk about this because there is an extreme fragility of cavus organs because of this pathology. And I have started by saying that it's important to promote and boost this research, which we decided to do it back in 2021 when Giacomo was first hospitalized. I think that Giacomo, who's in the hospital today, is also with us, is also logged in. He suffered a hemorrhage last week, very successful, overcome. The very first warriors are the patients, and Giacomo continues to keep us brave and courageous. When we first established the association, it was thanks to a friend of mine who actually aided us in selecting scientists that can focus on rare diseases, and we at the time contacted Alessandra Camerini, and she immediately involved in the second edition of the call for telethon, and that is when we started our work. And thanks to telethon, we can now summarize our work of 3.5 years by saying that we financed the 3 projects and allocated 350,000 euros. It isn't much, but at least for us, it's a lot because it has allowed us to contribute to the advancement of this journey. So thank you to you all, and also to the colleagues of Bank of Italy, to the families, the colleagues of Bank of Italy that have given us an exceptional support. I was talking about our friends. We have Dr. De Fusco, who's a dear friend of ours, and he will come to the floor, come to the podium. But before I do that, I would like to wish you all to find inspiration from a scientific point of view, but also from the daily activities involving families of young and not so young patients that must fight against this disease. Thank you. Now the floor over to Dr. De Fusco, and thank you all. And so De Fusco is a labor consultant. He is an expert in labor law, and is a person who's always stand by companies to find the best solutions to the benefit of the workers and the companies as well. I'm very humbled to be here today because we do not only have researchers and physicians here, but we have at the center of today the future of our patients, the hope for our patients. And I wish to greet Giacomo, who's logged and who's present, although virtually. I have decided to enter the world of research because I got very passionate about the essence of research. We need research, we need researchers, and I have studied the world of research. I was asked to study it, and I have come to realize how researchers, especially in the private sector, did not have not even the minimal guarantees to work in a serene frame of mind, in a way that would allow them to express their ingenuity and competence, so to eventually find the proper treatment. I believe that this is something that we have to remedy. We have to find the proper guarantees. So we must bring this sector back to the situation of it's true for the many other workers that are fully covered. And I know that you are very young. I see many young people here with us. And however, you have to make an effort and think in terms of 30 years from now. You need to have contributions paid to you. So from as far as I'm concerned, I will do my best. And let me just conclude by sharing an anecdote. I'm working with the Holy See for the 2025 Jubilee year with a specific reference to the world of labor. And we have several initiatives, especially on the 12th and 13th of September. We will talk about this. We are to focus on fraternity as well as on what being a human being means. It is inhuman to have researchers work in today's conditions, and it's human to give researchers dignified, proper conditions. So to all of you, I wish all the best. So we can now say that our symposium has started. We are fine with the schedule on our agenda. We have Dr. Filippo Gadenzi, who represents one of our partners. I mentioned Telethon, Bank of Italy, and the national broadcaster RAI. As I said, we need to raise awareness about these pathologies if we want to really advance. And altogether, we will be able to go forward. I'd like to pass the floor to Dr. Gastori, who will present the key lecture. So I will stop here, and I hope we will continue working together so to arrive to a survival that is going to be as close as possible to the general public survival rate. So thank you. So before I go ahead with this introduction that I was asked to do, allow me to add one more keyword for today's event, which is cooperation. And this is not simply the opposite of competitiveness or competition, but it is something so basic that I can only think of in terms of air, that if there is not, then we cannot breathe. So yeah, today we have distinguished representatives from different universities, Brescia and Florence, for instance. Certainly, we have symbols, we have images. If we look at the country we live in with the north, the center, and the south, then we know that that image as well has its meaning. As you see, we are dressed up as experts, but in the end, it's what we are called to do here today that is really important. And I'm very happy to open the event with Professor Novelli. I was a study, or I should say, I was attending the 5th year of medical school when he came to the university, and he was concerned with a specific field, and I remember studying on his book. So I'm very happy that today's meeting is going to be opened by a key lecture by Professor Novelli that will set the tone of our discussion and transform into reality what we are already knowledgeable in. Thank you. Over to Professor Novelli now.
Posso buttare giù queste così è qui dentro, vero? Qui? Ok. Bene, grazie. Grazie davvero di questa opportunità.
Thank you. Thank you for this opportunity. I'd like to congratulate on 3 institutions. Policlinico Tor Vergata, I've been working here for 40 years, and the Casa Sollievo della Sofferenza. We've started our journey there at the end of the 80s when it became the only research center in hereditary genetic diseases. And then Telethon I'm pleased and honored. I was the first one to be given the first grant financed by Telethon about myotonic illness. And then the second thing that I'd like to say is to connect with the dean and legal representative. We can no longer keep silence. We might have thousands of researchers who will be out of the market. New contracts should be drafted, and Europe is not actually acknowledging the current contract. So I hope that you and the Vatican might do something, can do something, because Italy definitely need these people. We have around 1,000 researchers who are in the market, while France can boast much more. The editor of Science, one of the most important magazines in the world, has just written what follows. We live in a paradoxical world. On the one hand, we have marvelous discoveries. The first child who was actually treated with the first experiment on a genetic illness on liver. And then on the other hand, we have a war-torn world. And this is totally paradoxical. And I think we can actually heed the call of this expert and of this magazine. And let me zero in on my masterclass. Let's talk about cardiovascular illnesses. Data are enough. I hope that we are not going to be using the expression rare diseases any longer. This expression is meaningless nowadays. Rare illnesses are helping us because they're paving the way to treating chronic multi-factor illnesses. And genetics has been doing a giant step forward. We have quite a few illnesses that are genetically passed on. We have illnesses and we have healthy people. We have dozens of thousands of people who are dead every year, and we need to do something. We are talking about illnesses or conditions. Let me see: hypertension, atherosclerosis, myocardial ischemia, cerebrovascular ischemia. Then we have and then we know family members who are actually affected by these conditions. These are staggering numbers. And then in the last 50 years, we've seen very significant progress that have allowed us to strongly reduce mortality due to CVDs all over the world. This is due to many factors, but especially to scientific knowledge of conditions. There are three main approaches by omics, which means complex, all-encompassing disciplines. Genomics, first of all. It allowed us to identify risk factors apart from classical factors that we've known from the 70s, smoking, cholesterol, diabetes, in CVDs. But the vulnerability genes, which lead to development of these conditions, we are using risk prediction systems in personalized genomic risk factors. And then you have some examples of these conditions: cardiopathies are due to gene mutations, and then we have the first few therapies associated with genomics. It's called pharmacogenomics, which can help us provide the right drug with the right dose to the right person. So we are no longer prescribing pills to everyone. Let me give you some brief examples, and some of experts will zero in on those. And then the causes of sudden cardiac death, genomics have changed the paradigm. We didn't know these conditions. Very often, children were used to die in their cradle, but they're dead because of genetic illnesses. But we had no tools to identify such conditions. But there are many other genetic illnesses, and genes are actually helping us to understand abnormalities in the myocardium. And then we have a number of cardiopathies. We have hypertrophic or dilatation-related myocardiopathy. And they're due to different mutations and different mutations which have different rates of prevalence. They often overlap, and they create more than one phenotype, which are associated to several illnesses, which can be gathered in these slides. These are the genes that are utilized for the screening of such illnesses. Let's talk about athletes. Let's talk about football players who die on the pitch. They die because of gene mutations. And very often, we have screens analyzing genes. The cost is affordable. You can read your own DNA by spending €300. But there's something different. You have to interconnect the identified variants. They're not black and white. Sometimes they're great, and they're difficult to interpret, and competence is needed. Machines are not enough. Very often we see in our health centers patients with machine-made reports with 300 or 400 gene mutations. What should I do now? Interpretation is quite difficult. This, you can see that experts are not in agreement. 30% of the cases see different interpretations of the very same mutation, and they are struggling to find the severity of such mutations. So the first rule of thumb of genomics and genomics interpretation. So interpretation is not easy. Well, yes, I have found a variant, but this is not enough. So we can find disease, illness, mutations. We sometimes we too often forget microscopes, but we should get back to this tool. What is the tool? What is the evidence of that variant? What is its functional aspect? And we have a gamut of tools that we might use by using algorithms and functional studies on cells to understand what really lead a variant to on people and on illnesses. And there are quite a few variants. Yesterday, we saw a new report. It's about the Marfan syndrome, and it shows how a number of uncertain meaning variants after the new classification of gene mutations. 40% has turned into 62% of meaning. So 40% were considered as uncertain mutations, and this rate has been increased to 62.5%. So this means that things are changing. And this is brand new data, and I just wanted to pinpoint it. So that you can understand how research is developing. Obviously, we like correlations, genotype and phenotype correlation. There's a generation of experts who like this approach. This is no longer the case. We are sure about this because sometimes mono gene illnesses are not related to one single phenotype. There are three pillars behind this: penetrance, exclusivity, and pleiotropy. But I just wanted to say, when there's a gene mutation, there are environmental aspects which change its expression. We'll see some mutation related to cardiomyopathies. Very often we were in the conditions to find family members of patients who had the mutation, but they were completely asymptomatic. They were actually identified, exposed by identifying the mutation in the patient, and then we found family members who didn't know, who were actually affected, and they were at risk of infection because, and now the study has been extended to family members. You see that patients were given a genetics diagnosis, which is different from a clinical diagnosis, which is related to reactive medicine. That gene mutation diagnosis is a proactive diagnosis, and these people were able to go through a procedure and lead a normal life. You can see this mother of this boy who was actually identified after the event to her son, and then she was given a genetic diagnosis, which was actually confirmed by a clinical diagnosis. What does it mean? We need to study this approach a little bit more. This is a study that was actually published last year. We thoroughly analyzed the arrhythmogenic left ventricular cardiomyopathy. We tried to understand how we could find genetical alterations with an ECG. We've actually found out something curious. If you thoroughly analyze one ECG after a genetic analysis, you might find signs that were not found before, and there's a new reassessment system of the ECG that can be used after genetic study. So it really, you can actually change your perspective on your ECG, and you can actually save lives by using a simple ECG, so which was not related to genetics. Genetics is extended in scope. We have new tools. We have new methodologies. These methodologies are quite complex. In some cases, we're able to find new anomalies, new ways of cell organizations or gene mutations organizations. We can actually study single chromosomes like the red dots, and we can find micro deletions or micro duplications, or we can also find optimal mapping. It's called genome mapping. By using more sophisticated systems, and we can find the whole genome with a 500 base resolution and with a new analysis capacity. The traditional genetic analysis was negative. The fibrillin exam was negative. Thanks to genome mapping, we're able to find a rupture in an intron. The gene was split, and all of this system was actually able to find this rupture. So on monogenic illnesses, we are now using incredible technologies. And then we have the so-called multi-gene diseases. Let me give an example. Atherosclerosis infarction. We have many gene variations involved. You see red, yellow genes that actually affect the process of the creation of clots. And then how many genes cooperate in this? Probably 300, 400. How can I actually analyze them all? Well, we have a new system. It's called polygenic score. It's a new way. It actually gathers together the analysis of millions of these variants, and this analysis assessed patients' risk of inheriting vulnerability or predisposition factors. Some doctors still call about genetic predispositions, but they haven't understood what predisposition is. We all have a vulnerability. The polygenic score actually displays the different variants, giving an augmented risk, an increased risk in some conditions and in some lifestyle context. And now, nowadays we can actually assess the cardiovascular risk of patients. You see a clear score, and we can identify high score patients. We can do this. And what can we do now? Well, if you have 100 patients with myocardial infarction and you actually assess them by this exam, then you might find a number of subjects who are at higher risk, red people, and then you find their risk. It's very similar to a monogenic illness, 3.8. Why are these scores so important? As my friend Katiris in Boston demonstrated, if you identify high-risk people, then if this score is well conceived, then you can reduce their genomic risk by 44%. These people were not actually sick, but they had a very high risk of developing illnesses. And Katharison is here in this picture, and he was actually quite provocative. He said newborn people should go through these exams. His parents died from an infection when they were 40, and he dedicated his life to this sort of studies. The community doesn't agree on this, and I think we need more than genomics, but we need some genetics is lost from these analyses. For instance, the point that you're seeing here, how genes talk to themselves, how they relate to the environment, genetic analysis doesn't see this, or the presence of rare mutations, which are due to de novo mutations, which cannot be foreseen. And they are very important. And then let me give you an example. You see this this caterpillar, and then you see a butterfly. They have the very same genome, the same DNA, but they're not the same, but they have the very same DNA with the same basic information. Then DNA is not enough to predict a specific phenotype. Who could have predicted this phenotype by examining the DNA of these two species? You wouldn't find any differences in their DNA. You might find it later when a part of our genome is hidden. It's called the dark genome. which is not DNA. It's something similar to DNA. It's a child of the DNA. It's the RNA. Only a part of our genome do proteins. They only do RNA or sequences of RNA, which never turn into protein. You see different names. They have regulation effects. They help genes function. They were only discovered in the last 10 years because they used to generate proteins before. But now you can see that after the year 2000, you see the quality leap that we have done in the last 10 years in knowing such molecules that are RNA, and the figures are staggering.
So here you have the study of transcriptomics, because right after the RNA, we have something that makes it work. So what was the contribution of this for cardiovascular diseases? First of all, the biomarker discovery or new biomarkers, which can provide you with information on the dysregulation of genes that do not work well, as in major heart failure. Some of these small RNAs, microRNAs, actually may interrupt genes, or there are others that do not code RNA, so they do not generate proteins, but they are important in the modeling of the vascular field. And the alteration of these microRNAs remodel the vascular systems and the vessels. And today we can also study single cell RNAs. We have many RNAs. Just let's think, we have 324,000 transcripted RNAs. See what they do. They have different forms, shapes, functions, and this is neither the place nor the time to discuss about them. But let me just focus on one class, the microRNAs. We have approximately 2,000 genes that generate microRNAs. MicroRNAs do not come from the sky. They are produced by genes. Some years ago, I started studying the genes that modify these microRNAs to understand where microRNAs come from. They have variants, polymorphisms, and work because once they are released, they regulate the transformation from a caterpillar into a butterfly. They make the difference. And in the myocardial infarction, they are hyper-expressed. This is MRI1, which is highly expressed in subjects suffering from myocardial infarction. And let me just focus on the role of one of these microRNAs out of the 2,000 that we know. See, they regulate the potassium genes, and they upregulate and lengthen the wave in arrhythmias. They regulate major cardiac failure as well as myocardial ischemias and infarction. And we have many of these microRNAs. This one actually regulates, for instance, a stable plaque in a coronary disease. So it does have a major impact. We can say that there is an unstable atherosclerotic plaque. Therefore, this specific patient has to be closely monitored. But look at what we see here in terms of the Marfan syndrome. It regulates the TGF-beta, which is therefore this is a regulator, and it has a most important role in fibrosis. thrombosis and aortic aneurysms. And I think that this is a field that should be further studied and researched. I think it's certainly something that would be worth studying. Now, the third point is proteomics. If we analyze DNA, RNA, we also have proteins. Proteins are many, are complex, are difficult to study. We did not have great tools in the past to study thousands of proteins at the same time in a tissue sample or in a cell. We had gas chromatography equipment. We had large size equipment in our labs. And nowadays, fortunately, we have the first roles being identified. So, small peptides that nowadays are analyzed. This is the new peptidic marker that is being analyzed. And now we have tools that can allow us to analyze 4,000 to 12,000 proteins in just one single test, as it happens with the genome. This is the SomaScan assay that is already available. It deals with the 12,000 different proteins. So if you want to see whether there is an excess quantity or a low quantity of one of these proteins, then you can do that. This is one example of the plasma screening that we carried out. The excess proteins are the light blue dots, and that shows you a change, and you can understand whether there is an infarction underway or not. We can, in this case, focus on plasma proteins. We know that proteins regulate metabolisms and the functioning of the cell. And in a cell, the metabolite carry messages that they are small molecules that flow in our biological fluids, and we can analyze it in a complete fashion through the metabolomic study. They are small fatty acids that can be analyzed and certainly identify ischemias. So we have a wide range of opportunities today. Considering the many tools that we can refer to, my friend Snifer from Stanford says that we should take a different approach to the tests and analysis we carry out. Think in terms of blood works, the time it takes, and everything becomes very cumbersome. So we live in a context where something can always be neglected. I told you how important the genome is, but look at the rest. We cannot say that all of these factors are not part of the health of an individual. This is the exposome. This is what we get in contact with by eating, drinking, and also practicing physical activity. And for all of this, we need tools. And we would not know that particulate would increase cardiometabolic risk because it interacts with people that have a different genetic susceptibility. As a result, we do have to have very sophisticated omic instrumentation. This is a slide from Stanford that shows you how it is possible nowadays to profile DNAs, RNAs, metabolomes, and biosensors as well, the microbiome that I'm not going to be talking about here today. And here we have billions of measurements. Imagine how much it costs, how long it would take for just one individual. So this is the challenge that we are to face up to. And here we go by making micro sampling with non-invasive systems, little drops of blood sent by FedEx to a lab, and in 24-hour times we get a response on over 1,000 different analytes. Is it possible to do all of it? Well, I don't know. We have a project that is trying to do all of it, and it deals with the genomic and exposomic analysis together with a major hospital in northern Italy. And we are trying to integrate it with the data I mentioned earlier on and the new technologies. So here we have a patient with a thoracic pain that comes to the ER, and we don't know what to do. What is it? Is it a heart attack underway or something else? We do not have a test. We start from enzymes. We consider the age of the patient. How long will it take us to actually do the proper discrimination of all of the potential reasons? So maybe in the future we will be more effective. And basically, we can now say that this that we have come to the point of saying that omics has improved substantially medicine recently, and nowadays we have precision medicine. It's a proactive medicine that can anticipate symptoms both for targeted treatments, but also in case we want to identify, to have an early identification of symptoms, all the way to the actual drug development. So we also go through the early disease detection. And for instance, if we had not discovered specific genes like PCSK9, my friend from France studied these first mutants, and at the time it was impossible to think of a drug that could block and inhibit PCSK9 because very few people had that mutation. Nowadays, thanks to that discovery, we have now a drug that is not only to be applied to rare diseases, but to hypercholesteremic diseases. So genomic is changing medicine as well. And allow me to quote Sidney Brenner, the Nobel Prize winner, who, and I quote, modern biology, and he said so back in 2002, modern biology has genes at its center because the real structures are cells and not genes. And today we can do this on the basis of omics. And thank you very much for listening to my presentation.
Grazie. Grazie.
Professor Novelli, grazie.
Sì, no, volevo
fare solo un passaggio. Allora, grazie per la sua scienza e grazie soprattutto per la sua capacità di saperla comunicare.
Professor Novelli, thank you. Thank you for your presentation and for your ability to share with us your information, your great knowledge, and I really appreciate your way of delivering these important pieces of information. We feel very grateful to you and to all of the scientists that work in research. You have accompanied us in an extraordinary world, which is your world, but that for most of us is an extraordinary universe where we are faced with extraordinary discoveries. And this shows how important it is for all of us to rely on your knowledge, on your science, on your passion, so to understand the mystery of the human body. You said that one pill for everyone no longer exists. So we need precision medicine, and it is what we need, especially in this context. I believe that this alliance that Custodi and Bertoldo spoke of between family associations, structures, and researchers is the fastest way to get to precision medicine, because it's patients that have to lead research work. Up to now, medicine related to patients as an object, but it is the patient that is the beginning, the starting point, and we start from the patient. So thank you. Thank you very much for being here with us. We can now pass on to the first session dedicated to principles of tailored medicine in people with a hereditary orthopathies. And I would like to pass the floor to Dr. Custodi, who will be talking about current molecular diagnostics in cardiogenetics. Thank you, Professor Novelli, for this excellent presentation of yours. Of course, my presentation has a bottom-up approach. Allow me to say that by listening to your words, reductionism is no longer valid. I will try my best to talk about what happens daily in our activities and say that we can already see the seeds for this very rich future that awaits us. Genetic tests, this is something that we are all very much familiar with, and we wonder, what is it for? Genetic tests, especially from the point of view of cardiogenetics, hereditary cardiopathies, and not only. So aside from the concept of diagnosis, which is given for granted, and that may confirm the diagnosis that the clinician has very clear in his or her mind, if the genetic tests clarify the situation, position the patient in a given way, and we are familiar with the genes, and not all hypertrophic cardiopathies have the same story. Their differences also depend on genotypes. The result of a final genetic test can help in what we know is prevention. We have genocentric official protocols. We are still with the genes at the center. However, they are quite important. We have the family aspect, which is not today's topic, but mostly the issue of treatment. In oncology, this is a fact. There are agnostic drugs, agnostic treatments, and this may also happen in other sectors. And I believe that in the field of cardiogenetics, this could be the second most important sector. So we must consider the relevance of genetic tests. That is due to the reliability, the understanding of the test itself, be negative or positive, and also the rapidity, because this is important also for secondary effects. Like first I answer, the sooner I provide the answer to the physician, the sooner the physician can act. That specific experience must be immediate. Now in 2025, genetic tests are not simply a relation between material objects, that is a piece of equipment and a blood sample. This has to be contextualized within a medical request, and it has to be analyzed in a critical fashion in light of the support given to us by bioinformatics and IT. So let me get into the details. In order for us to have a common language, we have to have a common language. And this is the only entity that 10 years ago provided us with keywords. And here you can see them. We have 26 keywords of criteria, 16 criteria, and their combination actually allow us to converge on the interpretation of variance. The clinical interpretation of variance nowadays refers to 5 main variant classes, and as you see, we still have variants with uncertain meaning. So what is the philosophy? Every variant generated by the best pipeline in the world, all of them have uncertain meaning up until when you can ascribe manually, semi-manually, or automatically some of these criteria. These criteria can be applied, as it was said earlier on, in an automatic or semi-automatic way, because they comply with digitalized principles. But there is also a set of criteria that can be correctly applied to variants only provided that the day hospital laboratory interaction is very strong, and this has to be based on principles that are not scientific, because they deal with confidence, knowledge, in a word, pure medicine. In terms of orthopathies, Marfan syndrome, many times we are faced with the sporadic cases, so it's important the de novo origin of this variant. But according to the accuracy of the clinical assessment, which is only partly determined by fate, we have additional criteria that can be applied to that variant, and that factor may impact the interpretation. In recessive disease, we must understand with the same whether the same variants are on the same alleles or on different alleles. This demands us to continue to cooperate with the family. So we have the first evaluation of the case that must be based on an alliance involving the whole of the family. Certainly, technologies nowadays allow us to overcome this situation in some cases, but this is not always so. In some familial cases, we see that some variants need to prove the co-segregation of the variant with the clinical case. These are tools provided to us by the American College that allow us to write something that has a sense in our report. So clinical accuracy of our assessment, this could be a reverse phenotype that is something that occurs after a preliminary results, and this happens in genetics as well as pathological anatomy. So if you are in line with the lab and you know how important these clinical parameters are in terms of re-examining the variant. So if there is a qualitative value, then you are even more motivated to do so. So not everything ends with the writing of a first report. Still, there is another point that is important, that is to introduce the other omics in a highly specialized lab routine, specialized in given sectors. So we standardize the attribution of criteria. We agree with the clinician. The family is available and willing to cooperate, and everything is there for us to use. But still we have an amount, a percentage of uncertain variants, but they may become less uncertain when we use a functional assessment and assay. So we get into a multi-omic or biomic context, especially in variants that alter the splicing, that is the RNA production and generation. But we may also have structural variants that target predicted effects. So in our reality, but not only in our reality, this is happening already in selected cases. We can have assays that can become the content of the analysis and test. That this is an example for the arrhythmogenic cardiomyopathy, and you see these splicing variants. This is the study of the transcriptome that has led us to the consolidation of the pathogenetic effect, and as a result we have turned an uncertain result into a more certain result. So this is a likely pathogenicity. This is an example of type 3 collagen that was given to us by the Gemelli Hospital in Rome. This is an uncertain variant studied by means of transcriptomics specific on fibroblasts, and this further corroborated the effect. Then in some situations we can certainly consider that what happens in the blood and fibroblasts can be artificially reconstructed in the lab, and this obviously must be done by those who can handle this. Now, trivial variants that can alter the structure of proteins, there are assays that we can use. Assays that can be standardized in the lab. And for instance, in our case, this is an AI phase. This is something that we have been discussed diffusely recently. So in our functional study, we try to understand this gene and its effects. At the beginning, it was research work, but nowadays we are trying to help our colleagues also to interpret variants better. This is not an easy task, but it can be done. We have a very wide variety of case studies.
Obviously, we can also use samples from patients. So cooperation is key. patients must be actively involved. Then we are at the border between diagnostics and research, integration with emerging technology. Now we can be more confident on data. Data can be found by using new tools. We are actually using long-read nanopore, and we're able to find a specific gene in a specific cardiomyopathy. Let's talk about uncertain meaning mutations or variants. They are a challenge of medical genetics nowadays. They are something new. They are counterintuitive, and they're against the oath. We can say, yes, we've found this new variant, but we don't know what to do with it. This is paradoxical for doctors. Doctors are facing ethical dilemmas. So we're actually trying to understand how to manage these cases. First of all, uncertain meaning variants. They are very heterogeneous. They can be classified according to different criteria. Some of them can be more or less precise. Some other classification criteria might be more descriptive. Others might have only scores. This form of uncertain environment is so because it has a bit some benign or some pathogenic elements. So this sort of three ways of classifying mutations can actually give us different forms of FUS. So we've tried to practically carry out new tests, and we're trying to implement a new approach. Our experience has been quite innovative. On 363 pedigrees with different diagnoses, and they were related to arteriopathies. And right now, we need to understand how symptoms are in line with your uncertain mutation gene. And statistics help. We are able to understand what you are observing a little bit better, and we are able to put in writing our rationale. Nowadays, on the basis of the relevance of the FUS, this variant can be part of a medical report or not. We've been working with the Bambino Gesù Hospital and alongside with the Pavia Hospital and the San Camillo Hospital in London, in Rome. We've been trying to replicate this experience to extend numbers. Now, standardization, figures are very important. Big data are very important because we need to use the very same terminology. But we need to work on a case-by-case basis because we might randomly find some medical cases that can help us. For instance, type 3 collagen. Yes, with all this rationale is okay, but we need more competencies. And then there are medical practices, single cases that go beyond work. In collagen 3, we find something different. We find solid evidence to interpret data. They're based on genotype-phenotype correlation. For instance, splicing variations are associated to a higher risk. in the triple helix, rather than other substitutions can be less important. So we need to be very cautious in interpreting substitutions in non-glycine residual substances within the triple helix. So we need to find more data after sequencing. And then we need to find other variants, and we know that other variants should be studied, like those on the end of the gene. And some forms of variants split the protein or delete the gene are associated to a lower risk. Now, this approach can be useful. It can actually be translated into a second opinion. We all been painstakingly working on pathologies, and sometimes we get contacted by patients or colleagues or peers. A peer of mine, once told me a specific story, like a paradoxical case. This case is the following. I saw a patient. He had hypermobility variant. I carried out a genetic test and I found a non-glycemic variant in the triple helix. So the answer was easy. You shouldn't have done a genetic test. But there was something in the family history, and then if you apply the American College criteria, then you get a wrong diagnosis. Unfortunately, the American College would classify it as an LP. If you go on automatic search engines like Franklin, then you might think you can replace the human mind, but other criteria should be used. And then I took my own responsibility and I told my peer, I don't know the meaning of this variant, but it doesn't confirm a vEDS diagnosis. And then other cases, there are other paradoxical cases. Family with a genetic test, which is carried out throughout the whole exome for other reasons, and they find a glycine substitution in the triple helix in someone which hadn't any suspicion of vEDS. And then we should wonder whether this test was actually efficient or useful. Self-referenced experts might say, oh, what can I say? This variant is part of the triple helix. It is actually noted down as frequently deleterious. It is extremely rare. Then I must say that this variant should be considered as a secondary finding, and this family should be followed up regardless of clinics. But ethically speaking, I don't know whether this is a legal and medical disclaimer or I really believe in what I'm saying. Thank you very much for your kind attention, and have a fruitful session. Thank you. Thank you, Dr. Castori, and I would like to take this opportunity to acknowledge all the people who have been actually following us, and I would like to thank all our interpreters. So I'd like to remind our speakers to speak slowly to help our interpreters. Let me invite Martina Berteotti to come up on stage to talk about personal medicine and hereditary arteriopathies, the patient's pathway. Thank you. Thank you for your kind invitation. Thank you, Marco. Thank you. Talking about this subject is very interesting. I'm a cardiologist, and this is a new opportunity to learn something new. When I saw the title of my speech, I immediately thought about of a journey. And in Italy, we use a PDA acronym, so patient journey. And I decided to split this expression, and I'd start with diagnostics. In order to do so, I'd like to step down and talk about practical aspects.
Ecco, dicevo, parto
Let me
a dire
start.
di cosa parliamo.
What are we talking about? We're talking about thoracic aortic aneurysm, TAA. It is not rare. 5 to 10 people out of 100,000 people every year, persons every year. They account for 2% of demises in Western countries. This incidence is probably underrated because autopsy are not always carried out in case of a sudden death. If we identify the causes of this condition, then the main role is related to atherosclerosis, hypertension, inflammatory forms play a role, and then congenital forms or hereditary arteriopathies play a key role. They can be syndrome-related, non-syndrome related. It can be associated to other extravascular symptoms, but overall, they actually account for 20% of TAAs, much less for abdominal aortic aneurysms. I'm going to talk about genetics, but I'm not a real expert in this field. We know that genes play a role. They might be responsible for these conditions. They code 3 main groups of protein in the ECM, like pharyngeus beta, or protein like milk. These genes do not explain all family-related cases, less than 30% in clinical practices. We have some studies saying that some genes must be studied, should be studied, when we have a suspicion. We have to look at these genes. Other genes are potentially associated with aneurysms, but they're not associated to dissection risk. Other genes are limited incidence on aneurysms, but they have extravascular features. And then other genes, and we have some data on them. We have only experimental studies, but they haven't been studied in clinics either. We are trying to carry out genetic tests, and we find very rare variants, very penetrant mutations, which have a high impact on clinics, but we cannot rule out polygenic contributions which might lead to predispositions in some families. And let me get back to diagnosis, and I'm more expert in this field. When we talk about gauging, measuring aorta size or sizes, we need to find out how we want to measure it. If we want to find aneurysms, we need to find the right way to measure aortas, and we need to interpret the reports correctly. We need to use the leading edge criterion, and then the other aspect that we should examine is the following. There are some differences in reports, and the delta should be of at least 3 millimeters. Probably this presentation hasn't been updated, or okay. Okay, we have probably a new version of this presentation.
Non abbiamo fatto in tempo.
Ok.
Allora, diciamo.
Ah, ok. Perfetto, no, pensavo che erano già, perché le vedevo già fatte. Beh, c'erano solo piccole differenze, ma solo per farvi vedere meglio le immagini.
There are only minor differences, but I just wanted to show you different pictures.
Sì, esatto.
Perfetto.
Era tutto. Ecco, sì.
I'm sorry. I just- Okay, I just wanted to show you new pictures, the leading edge measurements, and then the zeta or Z score. Some genetics in genetics use it freely, but it shouldn't be. It's not taken for granted in cardiology. Sometimes I read normal aortic root, and then we see a different Z score. And then we see that that size, a specific size, can indicate aortic dilation. So CAPAS says that we should have an homogeneous system of assessing Z scores. And then when we get to a genetic test in diagnostics, let's try and do it the right way. An algorithm was published in the last guidelines of our new association, and I think it's quite clear. Basically, young patients under 60 years of age, those who have an aortic dissection, always. Then in young with young dilation aortic, yes, with hypertension and a high Z score. So in other cases, they must have a significant family history. A Z score above 3 might lead to a genetic test. And then another key aspect is the next step. If despite all this, we are not able to draw a diagnosis, if we're highly suspicious, we need to reassess our patients in 3-5 years. Guidelines like passions give us more criteria to assess patients. If we see someone without aortic dilation, but octopia lenses without explanation, such patients should be assessed. A Marfan systemic score higher than 5. Those who have some features that might remind us of other genetic illnesses. This is important. We are experts, we take this for granted, but specialists who see patients on the ground, they should know this. So they should know that there are some elements to be investigated within the family. If you see dilation or dissection, you must know whether there are some spontaneous rupture cases in the family or uterus ruptures in the family. We know that in some conditions we might find a diagnosis without a genetic test, but guidelines say something.
So back to the guidelines published in 2010, we know that we have to carry out genetic tests even when we have a doubt, especially to actually customize the treatment of the patient. We have been talking about aorta so far, but we also we must also talk about aortic diseases. I have to say that I see many patients with a dissection of the aorta, and obviously they are more rare than the TAAs, but as a whole, they do represent a major problem. So if we consider also the associated conditions, and with respect to what we were saying earlier on as to the phenotype and genotype, some gene types are more associated with the dissection and dilation of specific vascular areas. This is an example. It's a study was published a few years ago. Patients suffering from vascular EDS, there is a genetic variant, and there are conditions that are more frequent in men than in women. As to aortic dissection, 75% of patients were men, and the coronary dissection patients instead had a different percentage. 61% of them were female. And then we have to now confront the spontaneous coronary dissection. This is something we observe quite frequently, although coronary dissections are rather rare. We have atherosclerosis by 4%, but a third of women younger than 50 years of age show dissection. So this is something that leads us to focus on associated conditions. Now, our hereditary aortic aorta diseases, the prevalence study are up to 3%. What really matters, and what I have learned to do, is that there is a condition, fibromuscular dysplasia, that can be up to 25 to 86% of cases in these patients. Just to further talk about this, following our patients means that we have to be able to make differential diagnosis. And in this case, we see that we find stenosis, but also aneurysm and dissections. We also find the involvement of craniocervical arteries. From a genetic point of view, many people come to my center for a genetic analysis. However, there is not a specific identified gene, although there are familiar aspects. But it's important to say that it's an X-ray analysis in patients with coronary dissection. We have to have an imaging to rule out situations such as this. This is a test that would allow us to identify potential aneurysm in other sites and further studies. I will not talk about treatments because medical therapy and cardiac surgery will be discussed by other two presenters, but it's obvious that the genetic pattern characterization is fundamental to follow a patient in the best possible way. Now, coming to the caring of the patients, what do we have in our guidelines? A first step is to try and understand how to keep these patients monitored from the point of view of imaging. Electrocardiogram is the easiest and the most important test to be carried out at least once a year, but the guidelines say that we should do it every 6 months. if there is an aortic dissection in between 40 and 45 millimeters, or resistant hypertension and a rapid growth of the aorta. But we also have other imaging that certainly, like the CT scan, and this should be carried out at least every 3 to 5 years or 1 to 3 years. These guidelines are very easy to be written, but more difficult when it comes to reality. And we must understand what would be the best possible path for every single patient. And certainly we must learn to understand what is the risk and then customize our strategy and have a better management of our patients. We also have a need to handle all of the comorbidities and the follow-up. I'm a cardiologist, and I must realize that it's not only a matter of the heart, so we have to be in constant good coordination with our colleagues and understand what are the other conditions that may exist, not simply the dilation of the aorta. Especially for the vascular EDS, we know that that is characterized by the fact that dissections may occur on not particularly dilated vessels. So here the monitoring becomes quite complex, especially in those that have already suffered an event and that have familiarity. But the guidelines and the consensus are quite vague. They talk about customization, so it's important for the expert center to plan the proper testing for each individual patient on the basis of the experience the center has. So you see that we need to interact with different professionals, keeping patients at the center of our activity. And this is what we do in our regional reference center in Tuscany, the Careggio Hospital for the Marfan syndrome and correlated pathologies. We cooperate with cardiosurgery, but not only. We have approximately 1,500 cases as a whole with genotypes, and we are part of the VASERN that is fundamental, not simply because it's a way for us to grow, but also in terms of certification and continuing training. So we spoke of PTDA. We also have a PTDA for the Marfan syndrome. We are actually updating it. A PTDA is the therapeutic diagnostic path, and it goes from the moment in which the patient comes to our center to the number of tests we may run, and also then the planning of the necessary follow-up that I mentioned earlier on, all the way to familial screening. Now, I also spoke of the medium perimeter vessels, and I realized that these patients are not homogeneous, and sometimes if the protocol is not specific, we may actually miss data. This is a retrospective as well as prospective study that gathers all dissection cases, and it shows that we have started a standard approach for all patients, starting with reporting and also carrying out of genetic tests. And this is a way for us not to lose track of most important diagnosis. So this tool of treatment and diagnosis, the so-called PTDA, is important, certainly, because it allows us to raise awareness in terms of HDAD suspicions, and working with other professionals, other colleagues. If we provide them with inputs, they may realize that their patients as well may have this aneurysm-associated pathologies that must be taken into consideration. It's also expedient in optimizing and uniforming the diagnostic path. And eventually, this approach may facilitate the cooperation between different specialists, still keeping the patient at the center of our action. Thank you. Thank you, Ms. Dr. Bertotti. Thank you for your presentation. We have come to our coffee break, a short coffee break, which is right here outside the conference hall. We will be back in 10-15 minutes. Thank you. So we can now resume our works, and I would like to give back the floor to our chair, Dr. Gaudenzi. I would like you to take your seats right now so that we can start works. We have the next presentation on our agenda. Just a few more minutes and then we will resume. Thank you.
Allora, riprendiamo i nostri lavori. La parola è alla dottoressa Silvia Morlino.
It is with great pleasure that I pass the floor to Professor Silvia Morlini, who's specialized in personalized medicine.
Grazie mille. Allora, io sono dedicata medico. I'm
a genetist from the Casa Sollievo della Sofferenza, where I have been working since 2020. This is one of the most important reference centers in central southern Italy. We have many patients, and of course we can gather many data as well. We are both a laboratory as well as a day hospital. I am part of the group of physicians who, however, constantly interact and cooperate with one another. It's a very effective synergy that has led to many interesting results over the years. In 2017, we started interacting and cooperating with Marco Castori, and then we continue along this path with many other professionals. We received financing for targeted research for multi-omics for rare diseases, and also we were granted a telethon funding. Now, getting into the specific topic of today, that is hereditary orthopaths. This is something that I believe you saw already in previous presentation, but it is important because it divides the different monogenic forms of orthopathies on the basis of the specific morphology of the proteins. So we have the contractile proteins of the smooth muscle system. So we also have different regulatory patterns and stimuli. We also phase on the diameter of the aortic bulb that is important for potential dissection. So today, however, we will focus on what happens before we get to the surgeon, that is strategies based on pharmacological treatments that can be used to solve the condition without resorting to surgery. So we have ESC guidelines that date back to 2024, where we have the syndromic forms of Marfan syndrome and the vascular EDS, which is similar to Marfan, but it's not the same syndrome. They are related, but so they were considered within these guidelines in order to provide a specific therapeutic indication. So here we are talking about personalizing treatments. Now we will focus on these two syndromes, vascular EDS and Marfan. As to the Marfan syndrome, MFS, we can have both a clinical diagnosis, but also a combined approach by means of transgenetic. It's not always true that transgenetic is informative. If there is a clinical diagnosis, the patient can be given the diagnosis and start his or her therapeutic treatment, and then examined over time, let's say after 2 years, and genetic tests may eventually give a diagnosis because of any improvement in technologies. As to MFS, you see the pleiotropic involvement, meaning that FBN1, this gene, expresses in different organs and systems. So we have the muscle skeleton system involvement as well as the aorta, but also the eye is involved with it may give rise to severe short-sightedness. So we have also an involvement of the lungs, and we will see more further down my presentation. So all of these different multi-system signals can help us in the diagnosis. Once the patient is given his or her diagnosis, then he or she can start specific treatments. Treatments that are usually based on beta blockers or beta blockers and ARB, and specifically there is an ARB that is protective, and it prevents specific treatments, but it may also improve the pathways that are regulated in the FS. This is really a precision medicine. Now, if we go to the vascular EDS, things become a little bit more complicated. It is rare among rare diseases. It's far more dangerous, and unlike MFS, we do not see a progression or a risk that can actually increase in terms of zeta score of the aorta. We have subjects that can have arterial ruptures on apparently healthy vessels with a very extended fragility that involves other organs. So we have bowels perforations, ruptures of the embryo, so the spontaneous formation of CCFs. So let's say that a patient of this kind often is diagnosed after the onset of the main vascular event, unfortunately, or when this event can no longer be remedied. So we must all be aware of this. So to recognize it, even by observing minor symptoms or signals, like for instance, translucent skin, or there are signs that maybe, for instance, hyper mobility and specific features of the patient's face. But 40% of the cases do not have the specific feature of vEDS. So the gene is called 3A1 that encodes with the pro-alpha-1 chain of type 3 procollagen, which is a major fibrillar collagen in the ECM, and it is expressed in various organs and systems, vessels, as well as skin and bowels. Now, getting into the issue of pharmacological resources, then we know, as the guidelines state, that there is a drug that should be administered. So the celiprolol, it's a beta blocker that ever since 2010, that is when this trial was first published on Lancet in 2010, started being used and administered as the key drug for this specific syndrome. So the trial was very important because it was the first one, but it did have some limitations as well. Information given before the classification that dates back to 2017 for the vEDS, because we had some patients that were not 100% to be classified as VEDs, so it was a very limited number of patients. But what is important is that we came to understand that there is a third decrease in the likelihood of vascular events among those who are administered this drug. And this information was further confirmed in 2019 by this study that was published by our French colleagues. And this also has limitations. It's retrospective, it's an observational study, but it has a wide number of patients, 144 patients with vEDS. And this was possible because France has a national system that has specific national centers where patients may go. So they were able to expand the number of cases and concentrate their energies. The study has confirmed the role of celiprolol in terms of decreasing major vascular events, and it was also indicated that the best possible dosage for preventive effectiveness was 400 milligrams per day. This is a more recent study, 2024, a study published by colleagues in Brescia, a most important study because it has confirmed this information on celiprolol, but further to that, indicated that for minor asymptomatic vascular event, there is still a very high risk, that is 14%, especially for specific categories of patients. So even though there is no control group, these researchers say that celiprolol cannot really fully be considered as a life-saving drug, but rather we should look for other kinds of treatments to be associated with it. But let's say that on the basis of these very important studies, the ESC guidelines have defined celiprolol as a treatment to start in light of such a diagnosis even with patients as young as 10 years of age. And following what our Brescia colleagues discovered quite recently, that is in 2025, this study was published between the association between celiprolol and losartan that contribute to the reduction of vascular events. So this was actually effective in decreasing symptomatic events with a relative risk of 0.37%, but there is a negative side, that is by combining these two drugs, we have recorded a higher number of hypertensive patients, but this combination of celiprolol and irbesartan is something the path to go. And we're not concerned only with the drugs to be used, but also drugs to be avoided. This is a study that shows how the risk of aortic dissection and aneurysms may increase in specific classes of patients, including patients with vascular EDS diagnosis and other autoimmune diseases. So this kind of antibiotic treatment is to be avoided. Usually this is a second degree treatment, but in urinary infection treatment and the digestive tract treatments, this is a treatment which is usually given to patients, but this is something that all physicians should be aware of. Now, aside from drugs, we should also be concerned with other resources. This is a kind of information that has been with us for the past 20 years. This is a very good article that focuses on the role being played by nutritional supplements. And we know that vitamin C, even 3 grams per day, is very protective, and it is prescribed. This is an important article that I like to quote. In 2024, the article takes a large number of cases susceptible to bleeding, and usually they have a positive beta score. They also had a clinical criteria for a supermobile vascular EDS. So this is a phenocopy, I believe. The lack of vitamin C can be mimetic of monogenic forms. And there's also another aspect. If we have a patient with vEDS and a lack of vitamin C, then this pathology can actually be developed even in a more severe form. So this is something that we should be very aware of. And here we have to your right-hand side of the slide an article from 2021 that deals with an effective treatment of a complex abdominal wound that was not scarring. So this was made possible by associating the vitamin C and the treatment. However, vitamin C can only is also generated in many ways. We know when Professor Novelli spoke of exposomes, that lifestyles play a major role. So we have to be proactive. We must have a varied diet because that makes us stay well, makes us feel well. We must stay away from behaviors increasing free radicals in the oxygen in our body. We must stay away from smoking, and we have to practice, and we have to consider mitochondrial DNA and exercise. There is a study that is certainly quite important because mild aerobic exercise, like for instance walking, can block the aortic dilatation and the fragmentation of elastin fibers. So no treatment, just exercise, physical exercise. This is also highlighted in the guidelines because aside from etiological diagnosis, in people with arthropathies and orthopathies, besides pharmacological treatments, it is lifestyle that becomes really very important. And physicians should recommend walking, having a good diet, keeping track of a good level of vitamin C and also vitamin D, as it is mentioned in some articles associated with vascular EDS. So we have to have an understanding of the whole of the context. How is it possible for us to understand the impact and validity of these treatments? Obviously, we try and hope to find biomarkers that may prevent the onset of major vascular events. And from the University of Brescia, we have different articles, one published in 2025, where it is said that the pulse pressure variability was the criterion used. This parameter seems to be very useful in terms of a therapeutic target, so to monitor patients with vascular EDS. But we also hope that in the future we will be able to dose markers in the blood and monitor the level of pathologies. I find this article from 2023 extremely interesting because different proteins were identified in the blood of patients with vascular EDS of different type. So it appeared clear that there was a dysregulation of some molecules in the blood, fibrillin 1 and 4, and a higher expression of TG beta 1. So what should we say? Is it a half full or a half empty glass? I believe it's a half full glass that must continue to be filled. And why? Because we already have international guidelines at our disposal that we can all use and implement, but it's also because we have drugs that have a mild to moderate effect, and we will see whether these combinations actually turn out to be effective. And we know that there is also the relevance of lifestyles that must be promoted together with treatments, and we have the support of patients associations that are the engine of our daily activity, together with the reference care centers that must centralize treatments and resources as much as possible. As our French colleagues showed, it can be done, and this will help us improve the case histories in the future. So thank you very much for your attention. I wish to thank the organizers and Mrs. and Mr. Gaudenzi, because they are the prime movers. So I also wish to thank the audience that is here with us today.
Thank you. Thank you. We're all committed to top up that glass. The glass is half full, it's not half empty. One main idea is to consider illnesses as something different from rare diseases. We need to increase screening tests, and once you do so, then you understand that rare diseases are not that rare. We have another speech by Dr. Augusto Donofrio. Welcome. Personalized medicine in hereditary arteriopathy or arthropathies. I hope you can hear me loud and clear. Very good. Good morning. Let me thank the organizers. Thank you for involving me in this event. I apologize. I sincerely apologize for not being with you. I'm unable to attend your symposium in presence due to family reasons. I hope that I can contribute to the success of this event regardless. Now, let me share my presentation with you. Just one moment.
Okay. Vedete le diapositive?
Can you see the slides?
Perfetto.
Yes, we can see them. Okay, now then, as to a personalized medicine in cardiosurgery, especially in hereditary cardiopathies, sometimes we suggest surgery. When we do so, we need to strike the right balance, and we assess the risk of surgery compared to a non-intervention risk. Why? When do we carry out a procedure? When we think that surgical procedure can be at a lower risk than keeping patients with their aortic diseases. We need to find the right timing of surgery. So the risk should be lower of the rupture of dissection risk. This is a very old article. It was one of the very first few articles focusing on timing of surgery. They identified a cutoff rate of 6 cm. Why had they such a high cutoff rate? Where data were found after low performance CT scans, and then the results were not brilliant, with a very high mortality rate on ascending aorta, higher than 4%. Luckily, we have improved this data, so we reduced this cutoff rate, cutoff threshold. It was only based on diameter. This cutoff was only based on diameter. You need to consider other criteria. We'll see that later. And this cutoff threshold dropped to 5.5, and then we see that this can be reduced, especially for heritable arteriopathy patients. And then the diameter criteria is being replaced, because in aortic dissection patients, the diameter was around 5.5 centimeters, but in many cases it was even lower. When we see the dissection of a CAT scan of a dissection, then we see a 20% increase. So the diameter we measure at this occasion is not the same as the one before. It's 20-30% higher. So if we bear this in mind, then you see that the vast majority of patients have an ascending aortic diameter between 35 and 45. So diameter cannot be the only criterion. So what should we base our decisions on? On genotype, phenotype, family history, and imaging. We're going to see why. What is the aim? Prevention of dissections and ruptures, and if possible, minimize in young patients the impact of surgery. These are the last guidelines of the European cardiology. They've carried out an outstanding work. They were able to identify the aorta as an organ. It's no longer considered as an anatomical part, but as an organ. So you see different task forces involved, and part of these specialized groups. We are actually deeply studying all these aspects, and you see that the situation is quite advanced compared to the past. We actually climbed the first step at 4.2, 4.3. Complications, the likelihood of complications is much higher at 5, and even higher at 5.75. So new guidelines are much more sophisticated than those which were based on diameter only. Many elements are considered, different thresholds are considered based on bicuspid or tricuspid valves, depending on risk factors, depending on whether the aortic root is involved or not. It all depends on the length, on the increasing diameter. It depends on the patient size. So the assessment of patients is much more sophisticated, and it's not only based on the diameter, and then other variables are considered by the new guidelines. Let me show you some criteria for this population. phenotypes. Dilatation phenotype of the aortic root dilatation compared to the ascending aorta phenotype. So, and then obviously the genetic predisposition. When we talk about hereditary aortopathies, you see something very important. You've been dealing with this since the beginning of the morning. The cutoff in Marfan patients is much lower. The increase of risk in this patient starts at 45 mm, but the cutoff rate is around 50 millimeters. This is valid for both the risk of death or aortic dissection, but this holds true for a general surgery. So if we need to make a differentiation. Hereditary aortopathy can be divided into syndrome-related and non-syndrome-related. Syndrome-related are, for instance, vEDS patients, and then we have non-syndrome arteriopathies. Guidelines have considered all these aspects, and they actually suggest a different treatment for every subtype of aortopathy. Guidelines have actually analyzed more studies, and in non-syndrome aortopic, we see that dissections are more frequent than in syndromes. So those who have a milk NIH1 mutation have symptoms much more frequently than syndrome-affected patients. And this is the GenTAC registry, 2,700 patients affected by Marfan, aortic bicuspid, other conditions like Ehlers-Danlos, and then you see the surgery can lead to different results depending on the alteration. And this was very important because we were able to develop new recommendations in the guidelines. Before the publication of the new guidelines, we submitted a new suggestion, a different suggestion than surgery, depending on the alterations in every patient. Patients with TGF alteration, the TGF-beta pathway genes, are associated with very low diameters, unlike patients with mutations that are associated with a higher benignity of arteriopathy. Let's see the last guidelines. They actually differentiate between syndrome-related and non-syndrome-related arteriopathies. They suggest Marfan patients undergo surgery at 50 mm. Hereditary arteriopathy patients have a cutoff rate of 45 mm, but they say something more. Marfan patients and high-risk patients, like family history of dissection, for instance, surgery can be considered at lower diameters, up to 45, and they say something more. They are even more proactive in some forms of Loeys-Dietz syndrome. They say the surgery should be carried out when gene mutations are present, with they suggest surgery with a 40 millimeters ascending aorta, much lower than the current rate. So Genetic characterization plays a key role in these patients. It's a game changer. No one would ever think about carrying out a procedure with a 40 millimeters aorta. But the procedure should be carried out when other features are present. Then guidelines are even more productive in non-syndrome arteriopathies. There's a difference between syndrome and non-syndrome arteriopathies. We saw that before. Non-syndrome arteriopathies display acute dissections more often. Non-syndromic arteriopathy patients, guidelines say that surgery should be carried out at 45 millimeters, but 42 millimeters in case of risk factors, or if the PRK gene is mutated, then surgery should be carried out at 40 millimeters. If we see patients that haven't been fully studied, then we would expose them to a risk. Let's leave genetics aside. Let's move to phenotypes. This is just as important as genetics. It is very important. We need to differentiate between root phenotype, aortic root dilation on the left-hand side of the slide, a pear-shaped ascending aorta. The aortic bulb is dilated compared to the right-hand side with a different shape of the ascending phenotype. So this differentiation was only characterized in bicuspid aortic, but it actually holds true for tricuspid aortic valves. This is a malign variation of aortic dilation because it is associated with a more rapid growth, more of the ascending phenotype. You see that the root phenotype on the left-hand side has a very high growth rate, higher than 0.09 every year. So this rate is associated with a more rapid growth of the diameter. Why? Because the aortic root has a different embryological origin compared to the ascending aorta. You see the left-hand side. You see the green part, the ascending aorta. It starts from the neural crest, while the other parts of the aorta have a different origins, and they have different cells, and they share the very same cells with large vessels and heart. Now, if you examine the family history of patients who suffered from genetic aneurysms, then you understand that regardless of the genes involved, you need to understand the degeneration of the median tunica. This is the common result of different pathogenic factors. If we get back to the phenotype, you see the involvement of the root, and it is associated with a higher degree of the decay of the median tunica. And so we see a higher malignity of the condition. Then we can also demonstrate this by means of two more studies. The left-hand side, the American Journal of Heart Association, it says that the aortic root dilation is more malign than the ascending aorta. You see on the left-hand side the matrix on the axis, you see, and the y-axis, you see the two diameters. You see the ascending phenotype on the left-hand side. Those who are below the line are the root dilations. The more you go towards the red, the more malign is the lesion. And so you can see at the naked eye that the aortic root is more malign than the ascending aorta. You see, you don't see bicuspid aortic roots, it's tricuspid, and those who had the root phenotype had a desiccations at a lower diameter. This actually confirms the importance of differentiating the phenotypes. This is important because avoiding surgery for root phenotypes gets to a worse outcome. You see, with no surgery and versus surgery patients. So we need to be more aggressive in surgery with some phenotypes. And when you see the hard endpoint, which are long-term survival, another reason to accelerate surgery for root phenotype is the idea of repairing the valve. The earlier we step in, the better the quality of the tissue, the higher the chance we have to repair the valve. Let's consider that we are talking about young patients. So if we can, we should refrain from substituting the valve so they have less implant consequences, fewer implant consequences. So let's see surgery that can be carried out. I'm not going to talk about the ascending aorta. This is simple substitution, and there's nothing to say. We should focus more on hereditary arteriopathy patients, and we should consider the aortic root. The first one is a standard surgery, a replacement of the ascending, the valve, with a bento procedure. We put a valved tube, it's a composite tube. There's a valve, and then a vascular implant, which replaces the whole root and the ascending aorta. And then we have a biologic bento, but we not use a mechanical implant, but a bio bento. We can actually spare a aortic valve. You might say, these are young patients and you're actually suggesting a biological implant. It sounds bizarre, but we have new technologies that can be very promising. It's too early to say that they can be used in very young patients, but the initial results are quite promising. Why aren't we using biological implants in young patients? Because we know that they decay, and there are many factors which affect the decay, namely calcification of the implant, but it all depends on the technology. It all depends on glutaraldehyde fixation, because it actually creates the side effects. And the presence of free aldehydes help the calcium ions. So calcium actually lays down and it leads to calcification. New tissues have been developed
i nostri dispositivi
companies
valvolari,
manufacturing valves are using new materials,
attraverso una
and by
dei
a
residui
capping
aldeidici
of
nascondono
aldehydic
i residui aldeidici agli ioni calcio, quindi i residui aldeidici vengono
parts
coperti
of
da
residues
queste piccole amine, creando
of
una
residual
fase C
substances
molto stabile, e questo evita il
are
deposito di
actually managed,
calcio
and
sui
calcium
residui aldeidici. In più,
no longer
queste ipotesi
stays
non vengono più
on
conservate
aldehydic
volutamente, quindi si
residues.
evita la
They're no longer
formazione
stored
dei nuovi residui aldeidici, e quindi tutto questo
in
porta a una valvola, a un
the previous
tessuto che
substances,
non ha dei residui
and
aldeidici liberi,
this
e non ha neanche la
we
conservazione in
don't have,
aldeide,
we no
anzi
longer
vedete, vengono
have free
conservate a secco. E
aldehydes,
tutto
so
questo
they're
sembrerebbe
kept in dry
estremamente
conditions,
promettente.
and
Perché
this
dico
seems to be very
estremamente
promising. Why?
promettente? Perché vedete, ci sono
It
degli
looks
studi
very promising. We
fatti
need,
in
we
modelli
have
animali,
studies
chip, che sono
on
dei modelli che
mouse models,
riproducono dei
reproducing,
soggetti con una
replicating
calcificazione
subjects
estremamente
with
aggressiva dei tessuti, e vedete che
aggressive
rispetto alle valvole
tissue
con i
calcification,
trattamenti convenzionali,
and
queste valvole con questi
these new
tessuti
valves
di nuova
seems to be very
generazione,
efficient because
vedete
they
che
use
queste
new tissues,
microradiografie
and you
non
see
si
that
osserva la presenza
macro
di
X-rays
calcificazione, anche
show
analizzando
no
i tessuti
calcification.
dopo il sacrificio
Even
di questi animali, vedete che la presenza di calcificazioni
after
sul
an autopsy
tessuto
on animals,
trattato con nuove
you
tecnologie
see
rispetto al tessuto
that
di controllo, la presenza di calcio è
new
significativamente
tissues compared to the control tissue
Tornando alle
show a
alternative
much
chirurgiche,
lower presence of calcium. Let's get
come
back
vi dicevo,
to
dobbiamo scegliere se
surgery.
fare
We
una
need
venta,
to
quindi
understand
sostituire
whether
anche la valvola,
we can
oppure risparmiare
work
la
on a
valvola
ventral
e fare una
or
valve sparing,
add a new
quindi sostituire soltanto la
valve or
radice,
spare the
ma
valve,
lasciando
substitute
la
the
valvola in
root,
sede.
and
Ovviamente
or in
questi
keeping the valve
molti studi
at its
ormai lo
place. There are
dimostrano,
many studies
la
who demonstrate
preservazione
that
della radice aortica
the preservation of the aortic root
con ortopatie ereditarie
in
migliora
hereditary
i
arteriopathies
risultati a lungo
patients
termine di questi pazienti, proprio perché si
enhance
riducono
results in the long run, because we do reduce complications related to the devices like the decay of the valve, endocarditis on implants,
la trombosi, gli eventi tromboembolici emorragici, ovviamente pazienti che
hemorrhages due thrombosis.
protesi meccaniche devono essere sottoposte
Obviously,
a regimi anticoagulanti
these
ambiti, quindi tutto
patients
questo
should
comporta delle
take
complicanze
anticoagulants
abbastanza
for a lifetime, and
prevedibili.
this might lead to foreseeable
Invece,
side effects.
per quanto
Instead,
riguarda la valve
as
sparing,
to
qual è il
valve
problema dei
sparing,
pazienti
what's
con
the
ortopatia
problem
ereditaria? Il problema
in
è la
these patients?
dilatazione
The
dell'anus.
problem
Quindi
is the
noi sappiamo la valvola,
dilatation
però è fondamentale
of some
stabilizzare
other
l'anus.
parts.
E come
We need
stabilizziamo
to
l'anus?
stabilize the
Attraverso o degli
annulus
rinforzi
by
alari, oppure attraverso
strengthening
un
the
intervento che
ring,
si chiama
or
reimplantation, che è quello che
by a
vedete
reimplantation procedure
queste
that
immagini
you
qui,
can see
che
in these images,
implicitamente, diciamo,
which
attraverso il posizionamento appunto dei
actually
punti sotto l'anus stabilizza e
by
include
adding
l'anulus all'interno della
stitches
protesi
underneath the
vascolare. Questo,
annulus,
vedete, è un intervento di valve sparing che abbiamo
we're
eseguito
able
qualche giorno
to
fa. Questo
add the
era la
annulus to the
settimana
valve.
scorsa, credo
This
fosse
was
martedì o
from
mercoledì.
last week,
Vedete, la
Tuesday or
valvola
Wednesday.
è
You see the
stata
valve? It
reimpiantata
was actually
all'interno
reimplanted
del
within
condotto
the
vascolare. Quindi questa è la
vessel
valvola
conduct.
aortica nativa
So
del
this
paziente, che è
is
stata reimpiantata all'interno
the
del
aorta
condotto
of the
vascolare.
patient, which
Vedete
was
che appunto
implanted in the
la
vessel
contrazione
conduct. You
dei
see
predeli è
the
eccellente, la
three
valvola tiene molto.
sizes
Non si
are
parla soltanto di radice
stuck
aortica e di aorta
to the rest
ascendente, ma dobbiamo
of
parlare in questi
the aorta.
pazienti anche
But we need
di
to also talk
arco
about
aortico e di aorta toracica
aortic
discendente. E
arc
nei
and descending
pazienti,
aorta.
soprattutto per quanto riguarda l'aorta
As
toracica
to
discendente, diciamo che nei
descending
pazienti non
aorta,
affetti da ortopatia ereditaria ormai
in
è
non-hereditary
quasi
patients,
sdoganata e quasi normale eseguire degli interventi di tipo
undergo
endovascolare, ma nei pazienti con
endovascular
ortopatia ereditaria le linee guida ci
surgery.
dicono che
The guidelines
questo
say
non è
that this
la
surgery
soluzione migliore,
is
proprio a causa
not the
della
best solution
debolezza relativa
due
del
to the
tessuto
relative
rispetto
weakness of the
ai
tissue
pazienti
compared
non
to
affetti da ortopatia ereditaria. Ma
non-hereditary
nonostante questo ci sono degli
arteriopathies.
studi
Despite all
recenti
this, we
che fanno
have
vedere
new
come nei
studies.
pazienti
They
affetti da
see
ortopatie
that
ereditarie ma trattati in centri di
hereditary
eccellenza in cui ci
patients
sia
who are
un
treated
multiteam
in excellence, in centers of excellence, with a multidisciplinary team, then results are similar to other patients, and even open surgeries like the elephant trunk, which actually involves an implant, might lead to good results. So what is the frozen elephant trunk? It's the replacement of the descending aorta of the aortic arch by means of a hybrid implant. It's a vessel implant and an endovascular prosthesis, which is actually joined together in a single implant. These procedures are done in aneurysm patients or in descending aneurysm patients or acute dissection. This is one of the patients that was actually they actually went procedures. You see those white stripes, the distal and proximal anastosis, and this is I'm very proud to say that we are very good at the cardio surgery, and we have a wide range of procedures to help arteriopathies, valve sparing, frozen elephant trunk, and also the endovascular treatment of the aortic arch, which introduces a new idea, micro-invasiveness, because these procedures, with the positioning of an implant in the aortic arch, can be done without general anesthesia. This is, I used to work in Padua, and this is an 80-year-old patient. He underwent surgery, and he was actually awake as he was undergoing a TAVI, T-A-V-I. Other features, other important features, they're related to the patient's height. So not only diameter, but also diameter compared to height. Low, let's say, short patients have different features than tall patients, and this should be considered in the guidelines. So comparing the diameter to patient's height should be done. And then we see something very new, not only the diameter, but also the length of the aorta, but also the volume of the aorta. So diameter by height, as if patients were cylinders. You see this image on the left-hand side, patients with a higher than 50 diameter and a longer aorta than 11 centimeters are associated to a higher risk. Not only the diameter, not only the shape, but also the length. And we're going to see something here in a while, the volume of the aorta. Let me draw this presentation to a close. The idea is to shift from an all-size-fits-all to personalized surgery. We only used to have standard surgery, but now we're shifting towards personalized surgery, which is much more heterogeneous, depending on the, let's say, on sizes and patients. I'm able to optimize and personalize choices of surgery. Now, I introduced the idea of the aortic team. I'm very proud to say that we have a very strong aortic team. This is a recent meeting. We have doctors discussing a very complex case. I'm sure that we also have an infectivologist pooling experiences and specialized knowledge is the only way forward. to work well, joining together the knowledge of everyone to optimize results in our patients. HTDAs represent a continuously evolving field, both medically speaking and surgically speaking. The management of these patients is a glaring example of a multidisciplinary approach. We must be proactive in terms of surveillance, in terms of the execution of the best possible procedure for every single patient. This is a glaring example of precision medicine. You see the various genes involved. We have a different indication depending to the gene. Some genes that 40, 45, 40, or 50. So this is something very accurate. And so we need to bear in mind technological progress in surgery, but also the better tests. So the support of imaging tests is key, and we need to manage these patients in centers of excellence. This makes the difference in terms of results and optimizing the outcome of our procedures.
Thank you. We are running a bit late, unfortunately, and you know that our agenda is very rich. So we have a Q&A time, but I'd like to call Mrs. Di Sirio to come to the podium. She will deliver a short intervention.
Mi sono sentita in dovere di intervenire in questo momento.
I thought it was important for me to take the floor right now because it is something I do on behalf of my daughters. I turned 74 yesterday, and I was informed about my diagnosis, vascular EDS. This, you can imagine, was a rather dramatic piece of information I was given. Following the test, I was subjected to, then also my two daughters had to go through this same test. That this diagnosis was actually followed the sudden death of my brother, who was only 67, because of the ascending aorta dissection. Previously, he had a less severe dissection, and so maybe he did not take care of it sufficiently, because sometimes this is not a very clear syndrome, but it's extremely dangerous. Professor Novelli this morning spoke of patients and non-patients in rare diseases that maybe do not exist, because when we speak about omics medicine, every single disease can actually have specific susceptibility elements. So I felt a bit less alone, but at the same time, I have come to realize in this path of mine, when I wanted to do the genetic path, and I was also, I have a specific familiar history, but I am a patient that was certainly helped by many different supports. Anyhow, I was not expecting this evolution in my life. So what is it that I want to say? In my experience, as Dr. D'Onofrio said, it was very important to be able to be monitored from the moment you are diagnosed with this syndrome. From the genetic test, I went on to specific and more accurate interventions on these tests that were carried out in Brescia. But I also did a constant yearly monitoring at the Policlinic hospital in Milan. But what I would like to point out is the relevance of associations such as this. And I'm very grateful to Maria Chiara, and I'm very close to her, and I admire her tremendously. So I'd like to say that I really felt very supported, and I know that this was not the case in terms of synergies and abilities to really carry out a common work. I live in Milan, I am monitored in Milan, and I told the persons that I interact with that I was coming and attend this meeting, but they were not aware of it. So I really believe that we should have a network of all these events because there may be synergies, common points that certainly proved to be extremely useful. I have not a scientific background, but I just want to say how important the world of research is, a world that is not recognized as it should be. It does not have sufficient economic recognition, but also in terms of moral recognition at the global level. So as a patient, I'm here with you, hoping that results will soon come. I am part of a reading group. We are about to read a book on a female doctor back in the 14th century, saying that medicine does not require excellence but courage. And certainly, this writer writes that her father wanted to bring care to everyone, paying the utmost attention to what was hidden rather than what was visible. And this is what we have heard so far. That is, we have to pay attention to what is not immediately visible, but I think that all physicians should really be extremely careful. We went to a very famous vascular surgeon to get his opinion on my diagnosis. 8 minutes was the time that he dedicated to me, with a very high fee that I was requested to pay, and that was it. So I live in Bergamo, but I will try and continue to participate in disseminating the need for such an awareness.
Grazie. Grazie Anita. È interessantissimo quello che lei diceva a fare rete, però io voglio ricordare che l'associazione ConGiacomoControVEDS ha un sito internet ed è anche su Facebook, e questo simposio rimarrà nella sua registrazione integrale, quindi sarà chiaramente a disposizione di tutti. Abbiamo preso esaurito un po' il tempo della mattinata. Proprio per questo. Dobbiamo gestire questi ultimi minuti. Diciamo
nel certo che rubo solo 2 secondi per introdurre la professoressa con me, la professoressa Betty Giussi, professore ordinario all'Universitario Reggio di Firenze. Quindi io faccio solo complimenti a tutti i relatori che ne disco livello, dall'ex professoressa del professor Novelli, tutti quanti, Marco Cassoli, Antonio Orti, Silvia Mondino, professora Costantino, diversi di quali sarai con noi virtualmente a cavallo, no? Giusto Augusto, tra un pochino. Grazie cuori, ottime, bellissime relazioni. Io non rubo tempo perché lascerei il giusto spazio alla professoressa Betti Giusti e se vuole un po' sono qui, se vuole appunto animare la discussione con noi, punto a lei questi ultimi che abbiamo per andare a Lancia, che comunque a Lancia è lungo, quindi qualche giorno lo possiamo ancora notare. Prego, professoressa.
Perché i relatori effettivamente danno una di grandissimo valore scientifico, scientifico che riunisce in sé la valenza assistenziale, la valenza di ricerca, la valenza formativa, che sono e devono essere nostramente ineludibili. Cercherò di essere sintetiche, cerchiamo magari anche di uniformare un po' e di incontrare le suggestioni che mi sono venute ascoltandoli. In particolare il Tor Pastori, Marco, insieme a tanti altri spunti degli altri relatori, caldeggiato molto sull'importanza della classificazione, su quanto ancora abbiamo da fare sulla classificazione delle varianti genetiche, anche per le ricadute. Abbiamo sentito appunto anche le ricadute sul timing dell'intervento. Quindi ecco questo e anche quello che ci diceva, no? La malleabilità che dobbiamo avere nell'interpretazione, quindi il coraggio talvolta di decidere, no? Di prendere una decisione. Ecco, questo come si in realtà poi incastona proprio la responsabilità medico-legale sulla testa di...
Allora, gli scenari sono infiniti. Io penso che non riusciremo ad uscire da questo impasse senza rischiare. Cioè io penso che ogni scelta in medicina comporti un rischio, altrimenti saremmo tutti dei consulenti di qualcun altro. E quindi un po' come l'anatomopatologo ad un certo punto una decisione la deve prendere, il radiologo una decisione la deve prendere, e tutti quelli che mettono referti a supporto del medico e del chirurgo, il medico ambulatoriale, insomma, di reparto, devono in qualche maniera assumersi. Stamattina girando col cane pensavo al fatto che invece dall'altra parte noi siamo indottrinati sul fatto che quando c'è un referto negativo siamo indottrinati e dobbiamo scrivere: questo però non esclude un'origine genetica. Te lo immagini un referto di anatomia patologica dove c'è scritto: questo non esclude che 1 millimetro accanto c'è il tumore? La stessa cosa. Cioè, secondo me, chi fa referti di genetica deve accettare il fatto che il referto di genetica non è un report tecnico, ma è un referto. E quindi devi assumerti la responsabilità.
Grazie.
Prego.
Fondamentale. Un altro aspetto importante è quello che è stato toccato sulla importanza dell'attività fisica e direi che sia nella gestione, guardo anche appunto poi gestisce il percorso, no? Terapeutico assistenziale, no? Vedo che anche il discorso dell'educazione dell'esercizio fisico, però ecco, è abbastanza, diciamo, forse provocatorio anche quello che ha fatto per noi Silvia, no? La dottoressa Morlino, di mettere in realtà un dato che prendeva spunto da un modello Molino, perché in realtà stiamo ancora probabilmente facendo non tutto quello che avremmo e che potremmo fare per avere delle evidence base in questo senso. Ecco, volevo una vostra opinione, ecco, anche rispetto poi all'indicazione, perché poi uno si trova a dare un'indicazione clinica che dovrebbe avvalersi di opinion paper, di linee guida Fantastico, quindi ecco, dal punto di vista di chi poi gestisce il paziente.
Grazie, no, è una domanda molto interessante, soprattutto perché poi il paziente è una delle prime domande che ti fa il paziente. Partiamo dal presupposto che nelle, diciamo, nelle ortopatie, ma anche nelle cardiomiopatie, c'è sempre stata il tabù sull'esercizio fisico che ovviamente può indurre un peggioramento delle aritmie, della dilatazione aortica e via dicendo, per cui classicamente si dice al paziente di evitarlo. Quello che è più preciso per quanto riguarda le ortopatie, di solito si dice di evitare le 3C, quindi competizione, contatto e collisione, che senz'altro possono peggiorare diciamo, la progressione degli aneurismi e altre anche comorbidità, come per esempio nel penso al Marfan con i traumi sull'occhio che possono peggiorare o causare comunque l'ectopialentis. Al di là di questo, però, direi che i due punti fondamentali sono il primo, che questo ci dice che fare il test genetico precocemente, questo me l'ha insegnato Jacopo Legotto quando nell'ambulatorio di cardiomiopatie, quindi non strettamente di questo, ma il test genetico precoce serve a indirizzare le famiglie ai figli, cioè un ragazzino che sa di avere una condizione genetica non viene indirizzato fin da piccolo a fare uno sport competitivo, quindi si scelgono degli hobby alternativi. Questo può sembrare banale, ma io personalmente ho visto il trauma di famiglie che avevano indirizzato il figlio a un'attività sportiva agonistica e era anche molto bravo, dovergli dire ora non lo puoi più fare, non è facile. Quindi questa è una cosa per me molto importante. Il secondo punto è quello che ci diceva anche Silvia Morino, che l'attività fisica non è controindicata, anzi è suggerita, anche le linee guida ce lo dicono, un'attività fisica moderata, aerobica, è consigliata per i benefici che può avere sui vasi. E non ci dimentichiamo che noi sappiamo benissimo che l'attività fisica aerobica moderata è un fattore che previene lo sviluppo di malattie aterosclerotiche e cardiovascolari e sappiamo che quando una malattia aterosclerotica si sovrammette a una problematica di cardiopatia o comunque di arteriopatia peggiora drasticamente la prognosi di questi pazienti. Quindi non possiamo curare un paziente, ora pensa alla cardiomiopatia ipertrofica dicendogli di non fare sport, poi gli viene la malattia tribasale del
It's
coronario.
important that we bear this in mind. It is important to stimulate patients to engage in mild aerobic physical activity. And together with this, we should also personalize physical activity. We have specific cardiopulmonary tests, for instance, that allow you to recommend the best fit physical activity for your patient. There may be other comorbidities, hypermobility, for instance, or other disorders. So a physiatric assessment as far as exercise is concerned would be recommendable. Thank you.
Io non ho molto da aggiungere.
I really have very little to add because I would go along the same line. In Casa Sollievo, where I work, we cooperate with the pediatric cardiology center. And this was due to my colleagues Ramtrani that wanted to interact with those of us who deal with genetic tests. He needed to be able to suggest the best possible solutions to the families concerned, and even a second opinion, a psychological second opinion. And of course, the accent, the focus is to be posed on daily lifestyles. For instance, starting to play a musical instrument could be a mild physical activity that can be done and which is very positive both to the mind and to the body, and it keeps your body going in a non-traumatic way. As for adulthood, there is another aspect to be taken into consideration. we have a lot of time to talk with our patients, and especially men tell us that they pick up huge weights, like a box of mineral waters. But if you have an arthropathy, then you should prevent from doing this. So we have to go back to, let's say, a kind of general practitioner's role. We must use our common sense. If I may, but I believe that you would like to take the floor. Dr. Foggi from the Italian Medicine Association. So thank you. I'm here not on behalf of IFA, but on my personal behalf. And I have to say that I have listened with the greatest attention to all of the presentations delivered. And I have greatly appreciated this day, this opportunity, and I would like to share with you some comments that have come to my mind. I'm mostly interested in pharmacological treatment and also facilitating research in this very field. So to eventually get to the development of drugs that can be of help to our patients. So let me say first that I am reflecting on a comment made on the fact that there is a rather substantial fragmentation in terms of data gathering, and in pathologies such as these that are highly complex, and when they get to the regulators, to legislators, they are really difficult to consider in order to get to a final decision. So I really recommend you to be all interconnected in a network and gather as many data as possible. And I also wish to remind you the impact on regulations, the impact of your research on regulations. I will certainly stay in touch with the association and promote the European guidelines also, for instance, in terms of setting up records of pathologies that can be useful to actually inform legislators and not only. This is a message that I would like to address to researchers. And the second comment that I'd like to make is keep a dialogue open with the regulatory agencies. There are many different instruments, informal instruments, all the way to scientific advisors. You can actually discuss with the policymakers as to the development of a new therapeutical indications, because if we start well from the beginning, then this can make a difference when it comes to the authorization of a new therapeutical indication. Some fantastic intuitions do not become a product because have not been handled properly. So the agency is to eventually authorize, but also to accompany and share along the way, so that this can be part of the development. And I apologize for taking up your time, but I wanted to share this comment with you. I am speaking on my own personal behalf, and I'm not talking on behalf of the agency, but this is all common sense considerations, and I believe that you can easily share this interest of mine. Thank you very much for your comments, because all comments that go to the benefit of research are certainly welcome. Thank you. If I may, I'd like to refer to what you just said and the records. Of course, we have done a lot. I'm thinking about the European registries and records. I'm thinking in terms of regional records for rare diseases. So we have done a lot. We have come a long way, but we need, as you said, coordination. And sometimes we were talking about this just early with a colleague, because this sometimes clashes against the real way of implemented. We have vertical and horizontal incompatibility that make these systems unable to actually interact, and information is blocked. There are bottlenecks that prevent information from being actually effectively circulated. And then I have one last question, and so we only have 5 minutes left. Now, the size of the aorta, I believe this was a point raised by several presenters, and it is most important in terms of the decision-making process, but also the management process. This is something that the care centers are very much aware of, but it may become critical when we speak in terms of all of those that interact with the patient, either when the patient is looking for a care center or at the level of territorial management. And maybe Professor D'Onofrio and others can further expand on it. Because, as I said, this may have an impact in this decision-making process. I apologize, says Professor D'Onofrio, because the audio was not very good. So to summarize my question, I was referring to how important it is to standardize sizes, and also how important it is to circulate the best practices. They should not only stay within reference centers, but they should be shared by all of those that interact with patients and address patients to either surgeons or specific centers. So what do you think? What is your approach about it? Yes, thank you. Obviously, there is a lack of standardization in terms of how this is dealt with, and it depends on different centers and also on the knowledge of the various professionals that interact with patients. In major reference centers, there is a very high level of awareness about this, but the issue is the local medicine, the territory medicine, the early identification of these patients in the population. In this case, we have to promote the culture of information at the level of primary medicine. And I believe that an association such as yours can play a major role, because scientific societies cannot do much in this respect, but patients associations, and you in particular that deal with these patients and that you organize these events, I'm sure that the dissemination of this information in the territory is most important, because a general practitioner with a CT scan and an aorta with a 42 diameter is not alerted, but if that general practitioner were to know that that specific patient with a genetic diagnosis actually has a very high level of risk, then the approach would change. And I personally believe that this has to be conceived at the regional as well as national level. So we should engage in refresher courses that would promote culture among general practitioners to have an early diagnosis of such patients, and this would make a major difference. And I believe that the early diagnosis is certainly fundamental. Mass screening action would make all the difference in terms of improving the final outcome for these patients, because if we act when we have the aortic dissection, then we have a very high level of mortality. Sometimes it happens during the night. Patients may have no understanding of their complications. So if we would go from 1 to 2% mortality rate to 30% mortality rate, depending on early diagnosis. Thank you. Thank you, Professor D'Onofrio. Thank you, Professor Betti. We have come to the lunch break. They will tell us where to go, and we will be back here at 2 o'clock. Very much.
Now then, let's resume our proceedings. Let's get back from where we left off. We identified a few keywords during the morning, in the morning. Alliance, converging towards positive outcomes, patient-centered approach, key role of patients' associations. We have said this throughout the day. A special role in terms of raising awareness about rare diseases, which are not as rare as you might think. Now, let me give the floor to Ms. Carmen Fotino. Commitment to research on rare diseases by the Telethon Association. Can you hear me loud and clear? Yes, good afternoon, everyone. Thank you for your kind invitation. Let me acknowledge Maria Chiara Pietro. We've been working together for a few years, as she said, since 2021. We started working alongside the association. Let me share my presentation with you.
Ok, come
as I was saying earlier, I'm going to discuss the Telethon Foundation's commitment on research on rare diseases. Our mission, advance biomedical research in treating rare genetic diseases. Our vision is to transform research outcomes into something real. Research is excellent, but we want to achieve accessible treatment. Such treatment should be available to our patients. This slide might look a little bit busy, but I just wanted to explain to you our portfolio. We actually look after extramural and special projects. We actually finance research projects throughout Italy to no-profit organizations, including universities and other research institutes. How do we raise funds? We use a competitive peer review systems system, all researchers compete between themselves, and this system is quality certified. We have a number of calls for tender, and we hope we can add many more so that we can actually cover all areas. And I'm going to discuss these calls for tender later on. We have a number of special projects. They are actually peer-reviewed. Our financed research is rigorously double-checked. We have many a special program of iron diagnosed disease program, a number of illnesses without a diagnosis as of yet, and then we have other special projects, including a biobank network extended throughout Italy. This way, we can actually swap very precious samples. And this is all the more true to just extend research network. And then we have some special projects about the creation of pathology registers. And I'm very pleased you talked about this this morning. Telethon is trying to meet the requirements of research, and then we have intramurus research within domestic research. You know that we have, for instance, our TGEM Research Center in Pozzuoli, near Naples. It undergoes a peer review process so that it can be replenished and refinanced. Right now, we are carrying out more translational research programs so that we can develop new approaches on rare genetic diseases. And then we have another research center in Milan, TGET, which works alongside the San Raffaele Hospital. It's actually hosted by the San Raffaele Hospital. And this research center is actually reviewed every 5 years. As all of you know, is focused on gene therapy and cell therapies so that these outcomes might be translated into patients' treatment. I don't want to scare you by using this slide, but I just wanted to tell you that we're fully committed from grassroots research up to our common aim, which is new therapeutical approaches for the benefit of patients. How do we select research projects? Our peer review selection process is very rigorous, and we actually implemented specific skills like technology transfer or patients, copyrights for institutes. We have a regulatory affairs office, clinical development. Throughout the years, we've been able to work with many pharma companies and other venture capitalist organizations, and we've been actually marketing genetic therapies against rare diseases. I just wanted to tell you something about our peer review process. I've already mentioned it. It's quality certified. Every single project, every researcher working for us undergo this peer review process. The key actors are the following: research program managers, and I'm one of them. I work and I manage all calls for tender that we are actually organizing within Telethon. We basically conceive calls for tenders depending on our strategy. We have our own vision, and we keep an eye on international guidelines about research. Then we draft all documents, and then we also prepare review reports, which we give back to researchers. And this is of the utmost importance, as researchers see the comments of their peers. These comments are very precious, and they can enhance their research projects. So research program managers look after expert reviewers. They must be internationally certified. We have many reviewers, many of them are Italian, but they must work abroad to avoid all forms of conflicts of interest, which might jeopardize the review process. And then we have other subjects, the scientific committee. We are part, project managers are part of the scientific committee. They avail of external advisors, and they actually decide the financing of projects. These are the different stages of assessment. We start from the so-called triage phase, bearing in mind the very high number of projects that were submitted. We have to be very careful. All researchers can apply, so we receive a very high number of research projects, and we need this very basic selection of projects. Every single project is assessed by the scientific committee, and then only the most interesting projects go through the next stage. They're assessed by score. And then we have the 4 review stage. Projects are actually examined by 3 reviewers with the support of 2 external advisors. They are experts, internationally recognized experts, who have specific skills on the rare genetic disease or on a specific pathway. And they actually support the committee. As you can imagine, one of our committees is actually made up of 28 members, but we have more than 7,000 rare genetic diseases. So we need to support the committee with external advisors. They assess projects, they add their comments and their score. The projects with the highest score go through the next stage, the study section. International experts come to Italy. They spend 2 or 3 days here, depending on the projects that are discussed. They meet with us, and they discuss on every single project, and then we take the final decision. The approval of the funds and the go-ahead is given by our board. Only high-scoring projects land to this stage, and they're financed depending on the funds which are available. This is only a picture of one of our study sections. This room is quite busy, and we discuss all projects for 2 days in detail to come to a decision.
Scusa,
there's some sorts of interference. Okay, let's try and move on. I just wanted to invite all those who are actually following us remotely to turn off their microphones. Let me zero in on the detail of our calls. Now, you can see here the development of therapies here.
Si ferma, diciamo, allo stadio 5. Ovviamente c'è
We have 5
ci sono
stages.
altri step in questa scala che non
There
abbiamo
are
sempre
other
tutti, perché
steps
i nostri bandi vanno a coprire
which
questa
you
prima
cannot
parte della
see
scala
them
dello sviluppo dei
because our calls
trattamenti
are
terapeutici.
about this part of the therapeutical process. Sorry, I've
Noi
got the
andiamo a
message.
finanziare quindi
Well,
ricerca
we
che va dalla ricerca di
finance
base alla ricerca
basic
preclinica,
research
e questi
and
step, questi
preclinical
stadi che voi vedete dallo 0 al 5 che
research.
vengono
You see
coperti
these
da due bandi
stages
nello
ranging from
specifico.
0 to 5, and
Primo
there are two
bando che va
calls.
a
The first
coprire,
one
diciamo,
is
lo stadio
actually
0, quindi sì,
about
ricerca di
the
base,
zero
ma
stage
ancora
basic
più,
research, but even
ancora
before
prima,
that,
diciamo, della ricerca di base, perché nello specifico questo
because
bando che
specifically speaking, this
facciamo insieme a Fondazione
call is
Cariplo.
organized alongside the Fondazione
Negli ultimi 3
Cariplo,
anni
a
ci sono stati
banking
3 bandi
foundation.
di
3
questi
calls have been organized in the last few years
insieme a Fondazione Cariplo. Cosa chiediamo qui ai
with this
ricercatori?
organization.
Andiamo a
What are
chiedergli
research to ask for?
sottomettere dei progetti
They
che
have to
vanno
submit
a
projects. These projects
studiare, come vedete
must
qui evidenziato in rosso da un
study
vecchio, quelli che sono chiamati T-Dark.
the so-called
T-Dark,
T-dark.
la parola stessa lo dice, l'oscuro totale, quindi chiediamo ai
So
ricercatori di andare a studiare quei geni per
researchers
cui
must
non
study
esiste nessuna
genes
informazione.
whereby we have
Potrebbero,
zero
con uno
information,
studio e quindi con un
but
progetto sottomesso in questo bando, andare a
these projects
a
might
studiare
help
meglio
us
questi geni o
study
queste proteine,
these
portare quindi a delle
proteins or genes
risposte che
better
poi
and
possono
provide
portare ad
us
una
with
ricerca di
answers
base
that
vera e
might
propria per andare a
lead
capire i
to
meccanismi.
basic research
Da
to
dove è nato questo
understand
bando? Questo bando è
some
nato da
mechanisms.
un'idea che è partita
Why? The
dall'NIH.
idea
L'NIH è
was triggered by
diciamo,
NIH. It's
l'Istituto
the
Nazionale della
so-called the
Ricerca degli Stati
National
Uniti. Un po' di anni fa hanno
Research
messo
Institute in
insieme
the
un
United
consorzio
States,
e ha
and they
creato un
created
database immenso
a
in cui
consortium
sono
with
catalogati
a
appunto in questo
huge
database
database.
tutti i
In
target
this
che
database, you
vanno
may
dal più
find
oscuro,
all
quindi dal
targets,
T-Dark, a quello che
starting
invece è già in
from the
clinica. E noi
darkest
chiediamo ai
to
ricercatori quindi di
those
andare in questo database
that
per
are already
cercare
present in
i loro
clinics.
target di interesse che
And we
rientrano in
want
questa categoria che si chiama
researchers
T-Dark, quindi su
to
geni o
look
proteine oggetto
after
sconosciuti. Come vi dicevo,
completely unknown
abbiamo
genes
fatto
or
3
proteins.
call, 3
So
bandi,
we
scusate,
organized 3
dal
calls
2021
for
ad oggi,
tender,
e in realtà in questo momento
starting
è
from
ongoing
2021,
la
and
quarta
we
edizione,
have
diciamo,
a
di questo bando. Abbiamo
a fourth
finanziato in
one
questi 3
currently
bandi
ongoing.
59 progetti
We finance 59
che
projects.
studiano 81
We
diverse
have been studying
malattie
81
rare genetiche
rare genetic
per un
diseases,
investimento totale
and
di
we have
più o meno
invested
quasi
around
14
14
milioni
million
di euro in questi anni.
euro
Abbiamo,
over the
come vi
years.
dicevo, è ongoing
And
in
as
questo
I
momento
said
la
before,
quarta
the fourth
edizione di questo
call is
bando.
currently
Abbiamo fatto dei
ongoing,
piccoli cambiamenti
and
perché adesso la
we
possibilità
have
non solo
made a
di
few
sottomettere dei
adjustments. Researchers
progetti
can now submit
della durata di
different
2 anni e
projects.
per un valore
They
di
can last for
250.000
2
euro, ma abbiamo dato anche la
years. They
possibilità di
can be
applicare con dei progetti di
250,000
1
euro
anno
worth,
e di 50.000 euro
and
per capire se effettivamente il gene che viene
we
studiato
can
ha una
also
relazione
finance
con una determinata
50,000
malattia rara genetica che viene
euro
proposta.
projects lasting for a year.
L'altro bando
And then
che
we have
abbiamo,
another
di cui abbiamo già
call,
ne
which
abbiamo
is
già fatti
active,
4 negli anni passati, dal 2021 al
start,
scorso
and
novembre c'è
4
stato
have already been
convocato
organized since
l'ultimo, che è
2021.
il bando multiround.
And
Come
we have a
vedete nella
multi-round
slide, in
call.
partnership con Fondazione
It is
Regionale Emilia
organized
Lombardia,
in
siamo in
partnership
partnership con
with
questa fondazione da
an
quest'anno.
an
Prima
organization in the
il bando
Lombardy region.
multiround era
The
fatto solo da Fondazione Tor, da
multi-round
quest'anno abbiamo, ed è anche
call
questo ongoing al
used to be
momento, in
organized
partnership
by
con la Fondazione Regionale
Telethon
per la
on its
ricerca
own,
biomedica
but
e
now
clinica
we've been
Lombardia.
working with
Questo
research
bando
institutes
prevede la
in
sottomissione di
the Lombardy
progetti che
region.
riguardano o la ricerca di base
We
o la
want to
ricerca
see
preclinica. La ricerca di base quindi
preclinic
andare a
or
esplorare
either
i
basic
meccanismi
research. We want to
per capire
explore the
meglio
mechanisms
perché
to better
avviene la
understand
malattia
why
e magari cercare
illnesses are
di
set on,
trovare un possibile
and we want to
target
try
per
and find suitable
eventuali approcci
targets
terapeutici futuri,
to
e
find
poi progetti
future
prettamente di preclinica
therapeutical
in cui
approaches,
il
and then
target è già stato selezionato e
preclinic
si va a studiare in un modello
projects, and we
animale
want to
piuttosto che in
study
vitro
murine models or
l'ipotesi che viene
in vitro
proposta.
samples
Come vi dicevo,
to
abbiamo già fatto 4
go
call dal
deep
2021 ad
into an
oggi.
assumption. We've been
Abbiamo
organizing
finanziato
5
117
calls.
progetti,
We have financed
84
117
di ricerca di
projects,
base, 33 di
84
ricerca
basic
preclinica. Come
research,
vedete, nella ricerca
3
preclinica
clinic
abbiamo finanziato
research
meno
POC,
progetti,
We financed fewer projects, but we have received fewer projects too, because they're quite complex, and researchers sometimes struggle to find POC research because they haven't finished their basic research stage. We've been studying 114 rare genetic diseases, and we have invested 20 million euros so far. Let's move on to something else. The seed grant calls. Maria Chiara has broached on them this morning. This initiative was triggered in 2019. It is organized in partnership with patients' associations. What do we do? Patients' associations come and see us, and they ask us to invest some money to invest in some projects. We support patients' associations by means of a peer review system. We have financed 77 projects so far, and we have studied 36 diseases. A seed grant call is in partnership with patients' associations, and it's about one specific disease. Instead, in other calls, we can actually study various diseases. We just want to focus on specific patients' associations and specific illnesses. We have invested 4 million euros so far. Last one, I just wanted to explain this to you. European call. It's a European partnership. It's the European Rare Diseases Research Alliance, the so-called ERDIRA. We set up a consortium in Europe on rare diseases. We are an active part of this consortium. We are a member of this call. It was actually created in 2024. The outcome will be published in 2025, at the end of 2025. So these projects are organized by consortia. Italian researchers will have to find European peers to create research programs, and local agencies will finance research projects in a specific region. Some figures. At the beginning of this stage, 183 proposals have been received. We only asked a 2-page report, and then we have a full proposal stage, and projects will be reassessed. 50 projects were organized alongside Telethon as a funding agency, and among these 50 projects, we have 7 patients' associations, because every single project requires the involvement of a patient association. And then the overall investment is 1 million euro. It actually covers one part of the development stage, which hasn't been displayed before, namely the later part of clinics. We basically cover another stage of research, and we are very pleased to do so, because we are actually covering the whole spectrum of the development stages. And we have been working hard, and next year we're going to open up a new call with clinical studies. So we're very proud of our work, because we are actually covering the whole range of research projects, moving on from 0 stage to stage 5. And I just wanted to show you our commitment over the years for vascular EDS.
Over the year, we financed two projects. One was finished in 2019, the other one in 1997. They were both focused on understanding the molecular mechanisms underlying the disease, and they also were concerned not only with the EDS, but other diseases as well. Then there is one project which is still active, and that is part of the TIGIT Institute with an investment amounting to 440,000 euros and focused on understanding the molecular mechanisms underlying the diseases due to defects in the protein production and elimination. And thanks to the seed grant initiative I mentioned a few moments ago, that was actually sponsored together with the Patient Association against ConGiacomo. 4 projects have been funded throughout the years by the Patient Association with 200,000 euros being allocated. And one of these projects was financed by the Italian Foundation with a 50,000 euro investment. I've come to the end of my presentation, and of course, I'm at your disposal if you have questions or comments. Thank you. Thank you, Dr. Fotino, for your contribution. Please stay with us. So if we have questions, we will address them to you. Now, we would like to give the floor to Annalisa Scopinaro, who will be speaking about the associated role in raising funds for translational medical research.
Sì, preferisco. Grazie mille. Intanto, prima di tutto, grazie.
Buongiorno e grazie a tutti.
So, good afternoon. Thank you to the organizing committee for inviting me. The title of my presentation is quite challenging and it concerned with what the Federation does only partially. But what I will try and do in my very short report is what we have said all throughout this morning, that is the importance of associations and how they contribute to promote the system, especially when we talk about rare diseases that are neglected. There are about which very few are interested, very few researchers that certainly feel isolated. But in our 25 years of activity, both the Federation and all the other associations that have joined us, we have done a lot of things. And let me just say shortly what the Federation is. We are the Federation that safeguards patients suffering from rare diseases. We are very inclusive. Right now, we have approximately 200 members in our federation, and last year we were recognized as an associative network, and that is very important thanks to Law 17 that regulates the third sector. And this only includes 180 Italian federations such as AFMAL, the Red Cross, that is major federations. So Uniamo is part of these major federations and associations. And we are not alone because we are part of the European Federation, but also with RDI, which is the international body that represents and supports the interests of over 300 million people suffering from rare diseases. Our Federation has grown over time, and let me just focus on figures. 200 members, associations that are members. Then we have 10 editions of our report talking about rare diseases in Italy. It has 345 pages, and I would encourage you to go consult and check this report. And And if you cannot find it, please inform me. Then we have 38 working groups. So we go from the National Committee for Rare Diseases to the coordinating group for clinical experimentation, and also ethical committees, including patients suffering from rare diseases. And this is very important because in the next few years we will have 150 new therapies and treatments that will have to be assessed by these committees. Then we have allocated for 130,000 euros in the past 2 years, 28 million people that we have been able to reach out to thanks to the last campaign. In 2023, we reached out to 32 million people so that we can disseminate information. And also, I have to say that narration has changed, especially since 4 years ago, we decided that because of a specific study that allowed us to have the incidence and prevalence of rare diseases together with the total number of people suffering from rare diseases, we have been able to include an extra 2 million people that in Italy have rare diseases. So we cannot say that it's only a few number of people, but we have a total of 28 million people that have an impact on the national health system in different ways. Highly expensive treatments or no treatments at all, and people that have to deal with palliative cares or other path that depends on the pathologies. Then we have the role. What is the role that we play? Why is this slide important? Because the relevance of the patient that is part of the processes within the different facilities. So what is the role? Patients have their own approach to pathologies. It is a unique, peculiar approach. Every patient has his or her own approach to pathologies, genotype, phenotype, exosome, proteins. So every patient has his or her own experience of the pathologies, but the associations actually are engaged in cutting across these experiences and transform them as a request to institutions. The higher level, which is the federations, do it even more because being the president of the federation, I have identified 4 requirements. First of all, the need to understand what is an early diagnosis and how important it is. Then we should be able to be accompanied all throughout our lives and also starting from adulthood to old age, not only in younger ages, considering all of the comorbidities that are associated with rare disease, and then research, clinical experimentation, and finally treatments whenever possible, but also the support that many of us must have to attain a good quality of life. So these are the 4 needs that we have to bear in mind, but we need for the system to try and meet these requirements. So it is important that as associations, we must be well organized, very proactive, able to put forth the proposals, be part of working groups with competencies that may help the system go towards the proper direction, the direction direction we need. We are also involved in training. There is nothing above us, nothing without us. And this is something that is also part of the UN Convention for People with Disabilities. We had a UN resolution in 2021 that guarantees people with rare diseases. And this is a challenge. The UN resolution is a challenge that we must welcome and that we must face up to in a professional way, because we have a unique experience, an experience that must be really appreciated, especially because we know what rare diseases are. And our point of view is very important and should always be taken into consideration. Translational research, which is the main theme of my paper, goes from basic research, and then we will hear more about it by our physicians, but then we have research work calls. But the question is, how does this impact on my daily lives? So for rare diseases, this is by far more fundamental than for other pathologies. Rare diseases are a most important benchmark for researchers, because without rare disease, we would not have many of the treatments that are available nowadays, including the COVID vaccine, because this is the real beginning of all the path of our research work. Translational research is most important. So how would we like people and patients be part of the research flow? Do we only want to finance research? Not at all. We want to be actors of research, because research not only adds knowledge to the scientific world, but it also has an impact on our daily lives. Unless we are key actors in the research process, then it will be difficult for us to find the way to find our request met. So we have to be part of all of the experimentation phases of the research process, not simply targets of research. And this is why we have to develop networks between entities, researchers, regulators, and clinicians. And then, of course, we have to try and contribute in the enhancement of fundraising activities, but also the channeling of national, international, European finances and funds to our field. We are not only faced with clinical requirements, but also demands that are associated with our quality of life. We heard about the case of the girl that was able to be treated of the CRISP syndrome, and just consider the many gene therapies that are now being implemented in different sectors. But much is being done to improve what we already have, to go from infusional treatment to a domicile treatment certainly improves our lives. But let's say that considering the very wide world of rare diseases, there are also those that are really advancing, meaning that we will be able to have even more resources for the ones that have not yet found a treatment. So what can I say about data, the interoperability of data, the privacy? The European data space is trying to regulate this, but it's not easy. We know that in Italy, we have 21 different health systems with different training systems, just to mention one aspect. And as regards rare diseases, we know that it's always been very complex to attract investments from big pharmas or pharmaceutical industries as a whole. Our market nowadays is attractive, also thanks to the fact that many many years ago, someone started to look at the European regulation on orphan drugs. But so what does this mean? It means that ever since rare diseases were recognized in 1998, then associations have really played a major role. Fundraising efforts undertaken by every single association is very important, and also Thundertown can play a major role. We have to finance research and also the approach to it, and we must continue to promote a peer review, a peer comparison, so to make sure that we are funding research work that qualitatively and objectively are valid, because in the past associations thought of financing a research project by allocating a 15,000 euro scholarship to a professor who then involved a PhD student in actually taking care of that specific research work. We know that fundraising entails a lot of work, a lot of energies, and it's therefore most important that we make sure that the funds we collect are then well spent. And what are the challenges? We know now that deontological and ethical rules are being reorganized in order to update privacy regulations. We must optimize the use of funds that are not very well connected one to the other. And thirdly, we should really establish a true partnership. Money from these single associations are not enough to support research. Do we have data on translational research work? No, we have not. There is no aggregate data that tells us how many research works are underway, who is promoting that work. So this is something that we should work at, and we are working at it as the National Committee on Rare Diseases. Telethon showed all of us how many funds are being invested. There has to be an organization of these pieces of information. This is what we are trying to do, and we are also asking more funds for research as well as tax cuts that would certainly accompany and integrate the regulations that we have at the European level for orphan drugs. We have continuously demanded extra funds, and we know that the Recovery and Resilience Plan has allocated 50 million to the research on rare diseases. This year, the call is going to be launched in June, and the total amount is 17.8 million euros targeting rare diseases. Certainly, we would need so much more money, but still, money is available. It's a flow that has never stopped. But from my point of view, that as Uniamo Federation has to ask institutions to be accountable. So where have these funds actually gone? And this is something that we should undertake in the near future by means of advocacy activities, because if we organize this well, then we can make the most of the resources available, because we can do many things if we can optimize our processes I am not a physician, I'm not a scientist, I have an economic background. So when I talk about optimizing, I means that we have to enhance effectiveness and the proper approach, still keeping a humanized approach to pathologies, clinicians, pathways, and the way that we should undertake in order to handle this terrible situation that may strike someone when he or she discovers a rare disease. This is my son who is suffering from a rare disease, and now he's 26 years old. This photograph is of some years ago, but this is really to say that I am leading a federation that is succeeding in reaching various results that allow for the meeting of many requirements, like an extended neonatal screening, as well as the national plan for rare diseases. Certainly, this may not sound as much, but I am telling you, implementing what we have is already very difficult, and we are one of the countries in Europe that are really leading in terms of the number of people, treatments, investments, and actions. But then it's very difficult when we reach out to the very families where there are persons suffering from rare diseases. My federation can do a lot, but if we together do not do everything that we can, then we will not be able to succeed in what we can really do. We have been having 195 meetings of working groups that succeeded in leading the way, but we need to continue ahead working in network and coordinating and cooperating. Thank you.
Thank you. Thank you. Let me acknowledge Davide, sitting on his armchair. Yeah, restrained freedom for him. Yeah, thank you, Dr. Scopinaro. Now we have just seen Davide, and we are going to consider the future of children affected by rare diseases. Let's move on to Mr. Ritelli. Multi-omics approaches for the identification of pathogenic mechanisms in vascular EDS. Good afternoon, everyone. Let me thank all organizers for the invitation, namely the association with Giacomo against vEDS. This association has financed, alongside Teleton, the multi-omics studies. So, vEDS is probably the most severe form of EDS. It has a severe obstetric and vascular consequences. Genetically speaking, it's relatively simple because vEDS is caused by specific autosomal dominant mutants with a number of de novo mutations. The COL3A1 code, a fundamental part of the ECM and connective tissues, and in particular abundant in the skin and halo organs. The number of mutations are missense multiplications.
dominio collagenico della proteina e delle varianti di splicing che causano lo skip di imprende delle zone colpite sempre all'interno
within
del collagenico.
these type of mutations have a so-called negative dominant effect because the mutated protein interferes with normal proteins in creating the typical triple helix. We see haploinsufficiency, and we often see more or less severe cases. Now, negative dominant autosomal effects. The multihelix is more susceptible to degradation, but this collagen ill-formed type 3 collagen interacts with the ECM, and it actually degrades the organization of cells and their mechanical research.
Sì, si può parlare leggermente piano e più al microfono.
Volevo recuperare un po' di tempo, anche perché l'abbiamo già sentito. Comunque stavo dicendo che
as I was saying before, Research Institute in Brescia organized this overall lack of organization in dermal fibroblasts. As you can see, vEDS patients do not organize COL3A1, but this faulty collagen is associated with a general lack of organization of other important components within the ECM, like other forms of collagen, collagen 1, collagen 5, elastin. Now, this homeostasis disruption is reflected in many symptoms, like subtle skin fragility, easy bruising, fragile tissues. Clinical diagnosis. It is made according to 2017 nosology. We have minor and major criteria. Suspicion is actually set when pneumothorax arises or minor symptoms arise. These might be considered only when minor symptoms appear. Luckily, children show only thin skin, visible skins, and easy bruising. Thanks to genetic tests, we're able to carry out diagnosis. And sometimes we're able to carry out early diagnosis. Before GI tract complications or organ ruptures. We have already heard this part on clinics, and I would like to show you the main results that we have achieved so far by means of the Per Giacomo Association and the telethon. The results are connected. The rationale is joint. Unfortunately, we don't have a curative treatment. As we said before, treatments are mainly symptomatic, with a few vascular prevention approaches. But procedures can be very risky due to fragility. Biologically speaking, despite faults in the organization and the maturation of type 3 collagen, we see other elements. This is the main cause of fragility of connective tissue, but we need to study more. As many mechanisms are involved. So we tried to identify potential therapeutical targets, and we carried out multi-omics tests, the profile and the expression of various forms of mRNA and proteins. So we're talking about analysis of proteins and proteomics. Why have we done so? Why this mRNA transcriptome analysis, 2023, comparative analysis of transcripts of different forms of mRNA with a vast number of dermal fibroblasts. We were able to assess variants in the expression of the genes. We saw the micro mRNA had been neglected, and we were trying to understand the altered process in the illness in vivo. This morning, we said that we've been studying proteins, and we're seeing new key molecules, and we're identifying new therapeutical targets. What are microRNA? They are small mRNA which regulate the mRNA post-transcription. What do they have? They have specific features because they can create specific bonds between mRNA and miRNA. They can reduce the degradation of the target, and they can suppress mistakes. And so upregulated genes might be responsible for lower proteins, but this regulation is very complex. We have more than 2,000 elements involved that interact with more 500 target messenger mRNA, which can actually be regulated at the same time by dozens and dozens of other elements. Let's see this study. Let's see how it is structured. Analysis of mRNA and transcriptome. We recruited 36 healthy donors and 18 vEDS patients. They had been characterized by the presence of lack of COL3A1. As you may see, these mutations are negative dominant mutations. 4 in splicing in frame. We had healthy individuals and ill individuals. Basically, all dermal fibroblasts show a generalized disorganization of the ECM. This was the main cellular characterization. We extracted mRNA. Let me open an aside on new generation sequencing. These new transcriptome techniques do not focus on causative elements, but we want to quantify transcripts. The number of transcriptions is proportional to the number of fibroblasts. We use these 2 kits, and we were able to quantify the level of expression of more than 20,000 protein coding genes. We used specific softwares, statistical analysis patterns, and we analyzed variance in expressions. And then we carried out the so-called gene ontology targets. We basically classified all genes depending on their functions on the cells, and we were able to place them in unregulated processes. As to microRNA differentially expressed, we identified targets, and then we focused on differently expressed to identify possible interaction networks between mRNA and gene differently expressed. I don't want to get into detailed analysis of the transcriptome. Left-hand side, we identified more than 3,000 microgenes differentially expressed. The majority of them are downregulated. 2,500 and 561 were overexpressed, upregulated. We identified a number of 137 mRNA in differential way, and 66 upregulated, others downregulated. You see on the left-hand side an image that corresponds to the analysis of main components, and you see the two cohorts show a stark difference in genic expression. You see a change in the mutation, and it actually reflects itself in the transcription of all genes. You see all genes differentially expressed. We can see down-regulated genes. I saw two members of autophagy, and up-regulated, I pinpointed ACT1 and TC1, which are key for cellular homeostasis. These four genes help us give us a biological meaning to this change in the transcriptome. Obviously, the gene ontology analysis was carried out on differently expressed genes. Let's bear in mind that these 3,000 differentially expressed might change 78 cellular functions and 135 biological processes. I tried to summarize them in this chart. You see on the left-hand side the genes, differentially expressed genes. On the right-hand side, you have the biological process which have been altered during two differences in expression. We have dermal fibroblasts, vEDS, show an alteration of autophagy. Autophagy is key to keep cellular homeostasis and to respond to stress. Cells are able to degrade both cytoplasmatic elements or malfunctioning elements like mitochondria and proteins which were altered or misassembled, including type 3 CoL, which was not properly formed. Homeostasis of the ECM, or the articulation of ECM, plays a key role in the illness, as you might see from the very large number of downregulated genes, which involve structural components to keep vessels safe, including proteins and enzymes which are aimed to the maturation of cells. Even the homeostasis of the plasmic reticulum is important. We see autophagy involved in cellular death, and all these elements are altered by the high number of differentially expressed genes. And then in the end, apart ACT1 and TSC1, vEDS fibroblasts show a differentially expression of elements regulating other elements used in regulating the growth and the motility of cells, as well as in genic transcription, as well as autophagy again. Before we draw the conclusion of my study, of transcriptome studies, I want to show you the myrenome analysis, which helped us identify 66 upregulated and 71 downregulated genes. But we need to bear in mind how they work. We carried out bio-IT analysis, and we identified potential targets of these ill-expressed mRNOMs, and we compared them with generally badly expressed. The rationale of this comparison is that a down-regulated mRNA might be regulated to an upregulation of the target. On the other side, an upregulated might be related to a downregulation of the miRNA. I'd like you to understand something. The number of targets it was more than 12,000. And this predicted we have more than 2,000 of them, which are differentially expressed genes. In the other approach, we identified the potential targets, 71 downregulated genes, 352 mRNA targets were upregulated. On the opposite side, potential targets of the upregulated dmRNA were 66, and more than 2,000 of the DGs were downregulated. So we see something very more important, upregulated dmRNA, because we still have anti-dmRNA drugs. The aim was to explore new therapeutical pathways. We identified a few upregulated mRNA, and the most important one is the AMR129B, 974 predicted targets, and 171 of these targets are downregulated targets. And Myrnam is upregulated. It was very interesting because it was more upregulated. There are numerous scientific evidences indicating that this mRNA is involved in the pathogenesis of the aorta, other heritable genetic diseases, including Marfan syndrome. Mouse models demonstrated that this miR29 is upregulated, and it actually contributes to the creation of aneurysms by interfering with the correct organization of collagen. Number 1, collagen 3, collagen 5, elastin, which is a key component to build the structure of the ECM, especially in the vascular system. So we can assume that this upregulated mRNA 29B might participate in vEDS.
So out of the 71 target genes of 29B gene actually support this hypothesis, because these downregulated genes actually participate in processes that we have seen previously, such as the organization of the matrix, the integrity of it, the homeostasis of the endoplasmatic reticule. But I'd like to point out that also the other upregulated mRNA participates in the vEDS pathogenesis, such as mRNA29A, that shares many targets with the 29B, and that may perturbate the key processes in different fashions. But so far we have focused mostly on the degradation of the target, but as I said earlier on, mRNA can also inhibit the target without altering its levels. This happens in 29B case as well. We also carried out the analysis of the cell proteomic element, and we have identified proteins that were targeted by the gene. However, Before we get on to the analysis of the proteomic data, let me summarize what we have obtained from these transcriptomic analysis. In vitro, we see the association with major changes in the expression of many mRNA. They are all involved in the organization and the homeostasis of the matrix, as well as in the stress within the homeoplasmatic reticule and in the regulation of the path. Now, let's look at the analysis that we have carried out of the intracell proteome on a very small number of fibroblasts by means of liquid chromatography and mass spectrometry. We will not get into the technical details, but just let me say that we identified 181 DEPs, most of which are down-regulated, and only 17 are up-regulated. So the analysis actually confirms or was put in evidence by the transcriptomes. That is, we have the key terms that we saw earlier on: integrity of the matrix, motility, growth, and so on and so forth. Now, to have a wider understanding, we carried out a so-called integrated analysis. To your left, you see that we have compared all of the differentially expressed genes with the proteins, and we identified 167 genes in common. We have 114 proteins that are only and exclusively protein modulated by proteins. So these 67 genes in common have a consistent expression. They are down-regulated both from the protein point of view and the RNA, messenger RNA. So we have considered also the difference in techniques and biologies. However, the comparison of these data has proven the relevance of both approaches. And on top of it, the genotology analysis of the 114 differentially expressed proteins that we had not identified at the level of the mRNA has contributed to make us better understand the pathogenetic mechanisms of the vascular EDS that are very consistent with the ones that we already mentioned.
Ma non solo. L'analisi integrata.
Because we have an integrated analysis between the proteome and the transcriptome that has strengthened the hypothesis of a central role played in B in pathogenetic mechanisms. We usually do not provide with water to make them actually comply with the time allotted. So this image that I'm showing you actually shows that we have compared all of the 791 targets together with the downregulated genes and the downregulated proteins. This analysis has allowed us to identify 3 genes that are downregulated, both proteically and here we have 171 downregulated genes at the mRNA level, but we have also identified non-proteins that are downregulated, and here you can see alpha-1 and alpha-2 of type 1 collagen, as well as elastin, that are essential components to keep the integrity of the matrix. Elastin, as we know, is very important because it gives elasticity to blood vessels. So these three proteins are important structural components, type 5, type 1 collagens and elastin. They are not only disorganized in the matrix and at the intercellular level, but they are also downregulated. This downregulation was further confirmed in an independent cohort of patients and controls by the images that you see here on the slide. So in light of these results, we ask ourselves whether inhibiting MIR29B could actually increase the level of mRNAs or proteins that are downregulated in vascular EDS fibroblasts. Now, to respond to this question, we have carried out various experiments with a specific anti-MIR that causes its degradation. First of all, we focused on the levels of mRNAs following the inhibition. So we identified the three common genes, including type 5 collagen and others that are also involved in autophagy. Now, and I will not get into the details, inhibiting 29B is associated with an increase in almost all of the mRNAs that we have investigated, we have studied. So what happens in terms of the proteins? And we decided to focus on the key proteins, type 1 collagen, type 5 collagen, and elastin. You see it on the right side of the slide, and you see that there is a significant increase in all of the proteins we have analyzed. So we have a proof of concept by which we can say that by inhibiting 29B, we actually increase the level of the MIR, and therefore, as a result, it could be that this is an in vivo target, but we needed one further evidence in the MIR29B can be regulated in vivo as well. And to reply to this question, we quantified the level of MIR in the blood, comparing control groups and patients, and we have identified levels of MIR29B that were far higher in patients with respect to control, the control individuals. I believe that I'm very close to the conclusion of my presentation. Our studies are now suggesting a key role of MIR29B, and this has an impact on the pathogenetic mechanisms of the vascular EDs. So it seems that it may bring about the dysregulation of the integrity of the ECM and the actual impacting the functionality of collagens. So considering it from a point of translational point of view, the results we have achieved are a strong conceptual evidence that may be at the basis of future research that may continue to verify whether it would be worth it to inhibit MIR29B. And this is the result would be an improvement in homeostasis, and this would be already a good result because it would improve the quality of life of patients as well as life expectancy. But from my point of view, we have to think in terms of something more final. Even if we inhibit all of the overexpressed MIR in vascular EDS, we still have the negative dominated mutation of type 3 collagen. And so the final solution would be a gene treatment, but we are still very far away from implementing such a treatment in vascular EDS. This is why we have been thinking in terms of more accessible and and innovative treatments such as the ADR-mediated RNA therapeutics. This seems to be perfectly fit to vascular EDS. Why is it? Because if we take into consideration another point of observation, if we consider the mutation spectrum that we find in vascular EDS, here in the table you see what are the mutations. And we have 14 out of 18 that are GA transitions. This percentage of mutations is clearly established in international databases, and it is this kind of mutation that we may correct directly on mRNA by leveraging the endogenous ADAR that can recognize in a double filament RNA molecule the adenosine and transforming them that are then read as guanosine. So basically, if we target ADAR to the mRNA, we can actually correct mRNA, which means that we will be able to recover the correct functional protein. And this is precisely this that we are working at. And what have we done in particular? We have identified these 3 strains, all of them with GA mutations. We also developed specific mutation guidelines per each one of the 3 strains, and this is the key element of our process because they have to be highly effective and highly specific, meaning that the ADAR must be targeted to the mutated not to anything else, or else we would add defects and not correct what is already present. So we have transduced the thermal fibroblast, and we are in the selection phase. We would have to extract RNA and understanding what the effectiveness of it is and see if we can recover the type 3 collagen matrix. So we believe in it very much, but we are not the only one, because many companies, also private companies, are massively investing on this therapeutic approach, which is very peculiar. So thank you. I wish to thank all of the members of our laboratory, also Dr. Carmine September's team, and all of the other members, but also we should be thankful to patients and healthy control that have allowed us to carry out this research. And we want to thank also the families that have participated and that have funded our research work. And thank you to you all for your attention.
Grazie. Cerchi di ritrovare la voce.
Thank you. Please try and find your voice, because it's quite important to, because your work is very precious, and I think we are starting to see the light at the end of the tunnel. Now, please, let's try to stick to our schedule. Sonia Teriaca.
Vi dico subito, avremo meno tempo per il caffè.
We'll have less time for coffee.
Sì, sì, no, però abbiamo bisogno di chiudere poi dei tempi stabiliti, perché dobbiamo rientrare
and we needed to be on schedule to help our participants get back home. We're seeing new information, and we're very willing to submit new treatment suggestions. And let me suggest this. We're not obsessive, but even researchers want to feel supported by patients' families, patients, because researchers, do you like Yannick Sinner, the Italian tennis player? You have many fans around you, and every time you score a point, it's a cheering moment, and you must feel supported. So we're not able to upload your presentation, so I'm gonna read a poem. Can we do that without slides? I'll try and explain to you my ideas without slides. I actually replaced Mr. Orlandi, and we've been working for the Marfan Center in Italy, for the vascular researchers at Tor Vergata. We've been working on many forms of arthropathy. Marfan arthropathy is a connective tissue which is due to the protein in the ECM. Its presence is key to create elastin. Elastin makes fabrics, connective tissue very elastic, which is very important. Marfan patients are lacking or have mutated or changed elastin. So these people are subject to dilation, and if untreated, these patients might go through dissections or rupture. Fibrillin doesn't have a strictly structural role, but also a regulatory role. And if this regulatory element, the TGF-beta element, is upregulated, it might lead to fibrosis. And we know that Marfan patients have mutated fibrillin, and this TGF-B is very active. In the last few years, we've carried out extensive studies, including aneurysms, and we focused on the MI 632. Why? 1632. Why? Because we started comparing different aortas, Marfan aortas, with patients with other illnesses, and we saw a different regulation of different mRNA, and we had an upregulation of this mRNA 632. So we focused on this mRNA 632 and study the role of it in the Marfan syndrome. So we analyzed the expression of different samples in the intima and in the median tunica, and we saw an upregulated in aneurysmatic aortas. This goes hand in hand with the reduction of one of the possible targets that we saw before with IT bioinformatic bio-IT analysis. We saw that Marfan aortas, compared to, they had this reduction of biomarkers in the endothelium, which was translating to a differentiated
there was a hypersecretion of collagen, and therefore this would lead to fibrosis. Once we clarify these mechanisms, we try to understand whether this microRNA had a role to play in these mechanisms. So we took aortas from patients that were not of Marfan syndrome and try and understand what its functions were. So when we applied this sequence, the RNA GB6 reduced, and that was the target, and all of the other processes were activated and triggered. And at the level of the differentiation, we went from smooth muscle cell to fibroblast. So we then try and understand what was the element that got to this major expression. There is the TGS beta expression, and TGF beta, we know that was associated with a pathway of this MER. So we treated aortas with the TGF beta, and when we did that, the microRNA upregulated with a very strong expression, triggering all of the previous processes I mentioned. So a degeneration of the aortic wall. Later then, we tried and understand whether this dysregulation could be present in the patient's blood for a prognosis. So what did we do? We analyzed blood samples that we took from health donors, patients with sporadic aneurysms, and also BAV genetic aneurysm, and we saw that Marfan in the blood as well had this very strong expression, and we continued our study thanks to a financing devoted to this pathology. And so we tried to identify this microRNA as a therapeutic target as well as a prognostic factor. So we took aortas and treated them with drugs that are usually used for hypertension with beta blockers, and the result was that the effect on microRNA was certainly higher on when we used losartan, and we were also able to decrease fibrosis markers. Then we compared the effect of this drug with a different treatment, that is, we administered these aortas with a specific sequence, actually an inhibitor. This inhibitor was administered individually as well as combined with aminolosartan, and what we appreciate is that when we gave the specific microRNA inhibitors, the microRNA decreases together with all the other markers, and this was an effect that was far more marked than that we obtained by administering losartan. As regards the blood, thanks to the Marfan Center, we continued to collect blood samples also from patients that come to day hospitals for their regular follow-up procedure, and we are correlating the microRNA levels in the blood, and we have compared these levels with a clinical parameter, that is the aortic group zero score, that is to be associated with gender, age, height, and weight. There was a very strong correlation between the level of microRNA, that is CT values, that is CT value, and the clinical parameter. There was a strong relationship between diameter and the level of microRNA. We must continue our studies as to the therapeutic therapeutic target, we have to confirm them in vivo, so to understand whether this treatment can actually work in vivo and also in clinical trials. We are continuing our studies, collecting blood samples from the same patient during the follow-up, so to understand what is the correlation with the pharmacological treatment at different times. Thank you.
Thank you for your presentation without your slides. It was very efficient, but we were not missing slides. Now we can put them on. It was just a joke. Now, 5 minutes coffee break. Now then, we have Lucia Amicale. Let's talk about fibroblast spheroids as a new cell model to study pathogenesis and identify new therapeutic targets in vascular EDS. Dr. Amicale, the floor is yours. Okay, thank you very much. Good afternoon. I'm brief in my introduction because we've heard a lot about research by Marco Ritelli. We all know that vascular EDS is caused by COL3-1 mutation, which code the pro-collagen, a major fibril collagen in ECM. This encoding happens in the plasmatic reticulum. After that, pro-collagen is transferred to the Golgi and sent to the ECM. Then proteases happens, and the two ends are sent out, and mature collagen is created, which keep its ends. Collagen molecules might assemble and they create fibers. Fibers give resistance and elasticity to the connective tissue. The pathogenesis of the EDS is not totally known. We don't have curative treatments. Since 2022, we have triggered a research project in cooperation with Professor Di Bernardo and Medina from Pozzuoli, funded by the ConGiacomo Foundation and Keratin Foundation, aiming at understanding the molecular mechanisms to define cellular phenotypes and to select therapeutic molecules. Let me show you the workflow of our first study. We actually selected 10 patients, vEDS patients, and 4 control individuals who gave their punch biopsies to build 2D fibroblast culture. We created 3D cultures. On 2D cultures, we dosed immunofluorescence and image at high content. On both cultures, we carried out proteomics and transcriptomes analysis. Then data were joined together to identify proteins and genes differentially expressed. We selected altered protein network in patients compared to control individuals to find molecules which could be suitable to therapeutics. Why using 3D? Three-dimensional environment is useful for cell-cell and cell-cell interactions. 3D cultures are actually generated from 2D cultures by using specific dishes, fostering interactions between cells. 3D accurately replicate the macroenvironment of the source tissue, both normal and pathological, and they represent an excellent model to study the physiological processes with alterated fibers. We are part of a European network for skin diseases and connective tissue diseases. Over the last few years, we have collected 3,000 patients affected by connective tissue syndromes. We actually selected 10 patients for a study, 10 vEDS patients who were willing to undergo punch biopsy. None of them are missense patients, which use residues in the last part of the helix, and one has an intronic variant classified as VUS. In order to define the effect of the intronic variant in the splicing process, we carried out the RNA sequencing from fibroblasts taken from patients and control people. The RNA extracted from fibroblasts and the data of the sequencing demonstrate that the intronic variant determined the deletion of in-frame exon, and this generates a protein that loses a part of the alpha helix. So we have an aberrant non-functional protein. This is a de novo variant. The parents don't have it. So a segregation study was carried out, a functional study was carried out, and they helped us reclassify this variant as deleterious. And this confirms what Professor Novelli and Professor Castori were saying, the importance of more studies to reclassify patients. We were able to find 26 differentially expressed genes. An analysis over them showed an alteration of genes associated with lysosomal, autophagosomal activity, proteostasis, but also disruption in collagen synthesis and the organization of collagen fiber. This data are in line with data submitted by Mr. Ritelli. Transcriptomics data on 3D cultures. We identify a number of genes. This number is significantly higher compared to 2D cultures. Why? Because cells grow in an ECM-rich environment. A further analysis showed an alteration in some pathways. Some pathways are associated with Fox signaling, Wine-Tintin, enriched cellular components are associated with ribosome, for instance, and we saw biological process related to the synthesis of fibers and to the response to external stimuli by cells. A less stringent enrichment analysis was carried out on differentially expressed genes, and we saw some altered cellular processes, including some of them which are very important. Some of them are very important in vEDS, namely the regulation of the migration of endothelial blood vessel cells and the regulation of the biosynthesis of the collagen. Some mass spectrometric analysis were carried out. We found 27 differentially expressed proteins, and a further analysis identified some pathways. For instance, some of them are associated with the metabolism of cholesterol and hyposignaling. Enriched cellular components are associated with ribosomes, low-density proteins, ECM, endoplasmic reticulum, altered processes are associated to the negative regulations of homeostasis, negative regulation of the response from external stimuli, remodeling of riboprotein at high density, and the metabolic process of proteins. Proteomics study on 3D cultures showed a double number of 2D samples, and a further analysis shows new pathways in cellular components and biological processes which are associated to the metabolism of the cell. So by joining together our transcriptomics and biomics data on 2D and 3D samples, we can say that there is a metabolic adaptation of the cell and a cellular survival mechanisms are triggered. We wanted to better differentiate phenotypes between patients and control individuals. We worked with Andrea Sbarbati from Verona, and we carried out an ultrastructural analysis by using microscopes on 2D samples. As we see from the images, patient cells show plasmatic changes, and they are characterized by bulges which show alterations in the cell-cell and cell ECM interactions. And then we see a significant dilation of the endoplasmatic reticulum compared to control patients where vesiculae are normal or are longer. This means a stress on the endoplasmic reticulum and a changed homeostasis. In patients, we see some lipofuscin granules. Their presence is related to a dysfunction of the mitochondria, a degradation of proteins, and also by elevations in protein oxidation. In order to characterize in a more sophisticated way the endoplasmic reticulum in a more sophisticated way and find a selective autophagy, we studied the endoplasmic reticulum under stress. We carried out immunofluorescence and high content imaging on both patients and control individuals. We fixed patients, we colored cells by means of a specific endoplasmic biomarker, a protein that is found in the endoplasmic reticulum membrane, and LAMP1, which is a protein which is widespread in the lysosome membranes. We took some signals. We studied the intensity of these signals, and we saw an increase in the level of expression of two markers, lysosomes and the one inside the reticulum, and the higher co-localization of the two markers inside the reticulum. This data suggests the activation of selective autophagy, which is important for the remodeling and the turnover inside the reticulum, both in basal conditions, in normal conditions, and in pathological conditions. Obviously, the reticulum is more activated under stress. Autophagy is activated, and some products are actually recycled by the cell. And this happens when cells are under stress, and they actually access a sort of energy-saving mode. If we want to join together known literature with our omics analysis, we can confirm that mutation in COL3A1 have quantity and quality effects. The reduction of expression for COL3A1 in the matrix, the secretion of ill-folded genes and the dilation of the reticulum are upstream mechanisms. Downstream, we see some downstream effects. Patients have disorganized matrices. They are altered in their protein components, and we see altered biological patterns with dysfunctional mitochondria, oxidative damage, proteostasis, selective autophagy, and then damage to the metabolism of cholesterol. These turmoil in processes might affect the direct or indirect regulation and differentiation of vascular cells in smooth muscles, which are involved in the contracting and the relaxation of vessels and in the regulation of blood flow and pressure and blood pressure. And so patients have a higher propensity to ruptures. The third aim was to identify molecules with therapeutical potential by using the repositioning strategy, a drug repositioning strategy. This method helped us understand whether a specific molecule, which had already been used in the past, which had overcome all trials, could be used for a new illness. So replacing a drug, repurposing a drug drastically reduces both testing, time, and cost. Let me explain to you our strategy. We basically went to CMAP database. We launched some queries. We looked for specific transcriptome profiles of molecules which were FDA approved drugs. So we had a list of differentially expressed genes, upregulated or downregulated. We analyzed 1,400 molecules. 400 had already been approved by the FDA. We used a computational approach, which was actually conceived by researchers, and we actually compared the 2D profiles with the transcriptome profiles which could be found in CMAP. This method, on one hand, helped us identify molecules with an expression pattern which was similar of the one in our cultures. So this is a direct profile, and molecules are potentially able to mimic, to induce the very same effects of the mutation of the COL3A1 in the cell. On the other hand, we were able to select some molecules with an opposite expression pattern compared to our cultures. So we have an inverted profile, and components can potentially fix defaults which are related to wrong mutations in the COL3A1. Obviously, we were interested in the inverted profile. So we used this approach, and we identified 8 molecules with an inverted profile, And the analysis was quite significant for 3D cultures. So these are only preliminary data. The therapeutic potential of this molecule will be experimentally validated on patients' cells. Patients will undergo functional analysis, including transcriptomics, and the data will be compared with known treated cells to assess a retreat of the phenotype. And we hope we can validate this data in human individuals. Apart from the approval of new molecules and identification of new molecules, we are going to go deeper in the study of the pathogenesis in vEDS by a secretome analysis. We are actually generating new cellular models which are much more similar and much more suitable to be used in functional and validation studies. We are UVEC are being submitted to CRISPR processes, and we're introducing the very same mutations identified in patients. In other cases, we're also assessing the idea of getting smooth muscle cells by reprogramming patients' fibroblasts in induced stem cells and then turn them into vascular cells of the smooth muscles. Let me thank you, all of you, for your kind attention. Let me thank the Gathering family and the ConGiacomo Association, and a big hug to Giacomo. Thank you.
Thank you, Dr. Michele. Thank you very much. Marco, over to you. Just a few words to introduce and present to you all Professor Colombi. She is the Marco Ritelli's mentor. And together with me, she will try to coordinate this last phase of our event. And we invite you all to pose questions to these last three speakers. Thank you, Marco. Before we start with the questions, I would like to focus on what we have been discussing in this very last session. In 2021, this was not present, and today it is. So this is thanks to the effort of researchers, but it's also due to the family and Gaudenzo. So we cannot even think of continuing ahead with our research work without you and with what we said about the relationship between researchers and patients associations. Myself, a genetist, am convinced that the research on rare gene diseases has to carry it out together with the patients, for the patients. We have shown you biopsies, blood samples donated by patients to carry out the research. It's not easy to ask patients to donate a biopsy or actually have a blood samples because of the problems they would encounter. But this is something that is possible in the world of the vascular EDS. And these three actors are fundamental. The results are extraordinary because there is no one else in the world today that can talk about molecular approaches and that actually lead the way to possible all therapies and treatments. We are laying the grounds. We do not know whether they will work, but we are opening the way. And I wish to thank the family Theodor Gaudenzi and the patients together with the researchers. Do not leave now, because I'm talking about you. Okay, you had a shuttle bus to catch. We spoke of Careggi, Tor Vergata, Brescia, and San Giovanni Rotondo. These are the facilities we heard from. This means that it is a group that has interact as to exchanging samples, setting up records and registries. This is the challenge I launch to you all. But now, after this, I'd like to go straight to the issue, to the matter of the question, and I will start from you. So please join me, because you said something that caught my attention. You spoke of in vivo biopsies, but you spoke of Marfan syndrome. So the Marfan syndrome, you spoke of biopsies. So my question is, yes, these are very rare cases because many a time we had to use models of other aneurysm and simulate a Marfan syndrome, mostly to try and confirm the data, because with just one sample we cannot repeat the experiment. But this in vivo sample was very useful because it's important that we focus on ECM, the extracellular matrix, and we should also look what is outside the cell. So my question is to say that in Italy, we do not have smooth muscle cells and vascular cells that can be used to multiply and verify what you just said. We have very mutated cells, but yes, you are right. We would need to act in different ways, but we have used in vivo samples from patients with a different aneurysm, and we are trying to confirm this in the Marfan syndrome cases. I already know what would be the answer, that it's difficult to have these cultures because certainly we cannot have a sample to be taken from a vEDS patient. Yes, it would be very complicated, but this was concerned with the ECM, and we needed a model that could be as close as possible to the patient's aorta. This is a paradoxical effect because when we started planning the study, which is really important, it's based on samples taken in the operation room. That is a patient undergoing a surgical procedure. We can a tissue sample can be taken and be made available for following tests. But this happened some years ago. Why am I talking about a paradoxical effect? It was simply because 5 years ago, the center had half of the patients that it deals with today, and we had procedures in the 15 to 20 domains. So we said that we should delay operation procedures as long as possible, and if possible not to have surgeries altogether. This would be the third level of treatment that we would like to avoid. So what happened? This reference care center then acted as a center. So taking the patients, providing treatment, while at the same time researchers are engaged in research work. So the amount of patients that go to the surgeons actually dropped quite drastically. And this is very positive. It's a positive result because nowadays we have a smaller number of samples on which to conduct this kind of research. But we should also highlight that the successes that surgery procedures have decreased, and being a cardiosurgeon, I believe this to be a great success. So we continue to work with our colleagues. We will continue with this in vivo sample analysis, and I believe that here we have very strong centers, 4 centers. Some of the centers are not here, but we need to network. We need to provide and exchange clinical molecular gene data as if we were just one single centers with different local regional offices. So Professor, I agree with you 100%, and we will keep you posted as to our next steps. However, it is also true to say that we have to launch this approach, and we must set things in motion. I do not know who will be the leader, but this is something that must be done. So let's say that the association could be the coordinating element. The association could pull everybody and have this meeting of minds and research data. Today, we wanted to dedicate our event to families, but also to the researchers that have met here. This is a unique opportunity. We must continue to exchange data. May I put forth a proposal? This is a yearly symposium, and maybe it would be quite positive if you could organize virtual meetings on a periodic, regular time frame, and we could also involve the legislators in this process, because we know that time is the most important factor in the case of these diseases. I agree, this is a very good idea, and what at the beginning I thought was rather limiting, that is, we see all of the different types of vascular EDS. And I was telling Maria Chiara, why is it that the association does not concern also with other diseases? But nowadays I realize that this is even more effective, because if we extend to other diseases, then we may not be as effective as you are in this moment. This is a strategic approach. We must focus on VEDs. We must pool all of the centers, exchange materials, exchange knowledge. But I think that we really have to be thankful to patients, associations, and researchers. Of course, I'm not mentioning the clinicians, because to me, the clinicians are researchers as well. Thank you. I think this should be immediately organized together with Maria, together with Pietro. You may decide on how many times you can organize virtual meetings. Marina could be part of the coordination, because right now it seems that she's rather free, although it is not true. So what would be the proper frequency for virtual meetings that you may organize, let's say every 2 months, every 3 months, so that you can keep on exchanging materials? For instance, we could have a strategic meeting before summer, and then we can on that occasion decide what is it that we can put on the table, and then we continue strategizing. Interpreters apologize, but the lady is speaking not into a microphone. Yes, yes, you are right, but we are the founders. We first start, because if you open up to people who are not interested, then, but it's also true to say that the centers in Milan is concerned with many patients, not to be these patients, but I believe that nevertheless this could be useful. Not really, it would not be useful, because we identify what is the advantage of being a very well-defined group. This is really a most important achievement of the association. We focus on a specific item, and this could be a model, an example to be followed. This is not to exclude anybody else, but we have to focus on what we have, because this would allow us to get the best possible results. One of the 2 projects, we are now in the 3rd year of financing. This is a project by Professor Fantina from Milan, and this research is certainly a reference research. It was considered as a very challenging project, but the point is that Milano is not concerned with the patients. You know that we are part of the Fantin project because we provide cells, and we also provide consultancy work. So the idea is that everyone has a way to contribute. Maybe you were referring to the center of Bassotti. Just to explain matters a bit more, I believe that Marina was talking about the fact that in this first phase of actually establishing cooperative projects, we should stay away from the same error that was actually made by the Ehlers-Danlos Society. So it means that if we want to plan the next 5 years and the path that we have to follow, plurality is important, but democracy could be damaging. So in some realities, as you know, there is the steering committee made up of 3-5 people, and then working groups. So I believe that Marina was referring to this, but of course we know what you're mentioning very well, and I believe that Bassotti, when she will be involved, obviously, speaking of the cuff in recruiting, compiling data, and also in comparing specific projects that we assign priority, because in the field of biomedics, even if you start with just one pathology, you can go an infinite number of avenues. So the advantage of already having a history of medical researchers actually allows us to filter the options, so to actually get to 3, 4 options. It's not that we want to be exclusive. There are colleagues from Bologna. There is a new group that is now being established in Pavia, following the various changes in governance. So let's say that we have to be clear. It's not that we want to be exclusive. We do not want to exclude anyone. We want to consolidate the cooperation among the centers that are already part of this network. We have started this sharing process already. We must continue. We must then open up to others, so to expand and amplify the effects. But I believe that right now our need is to consolidate our cooperation so that we no longer have 4 centers but just one. That is a real coordination among these 4 centers, and that would enhance and boost research possibilities and opportunities. So we are now getting to the final stage of our event. We have to draw the conclusion, and then Professor Bertoldi and Professor Castori. Thank you. My conclusion is a very simple one. Thank you very much. You spoke about 5 years. 5 years are way too many for us. Giacomo is in the hospital, so we have to speed up. And using artificial intelligence together with our human intelligence can allow us to elaborate data at a faster rate. And this should be considered. We can reach out to counterparts in the States, especially in Pennsylvania. I have good contacts. We're operational. We are willing to work with you. We are your tools and resources. Thank you, Maria. Pietro, as a father, you have conceived this network. You have given to it its conceptual structure. The network is a strong point. It supports all of our activities. It is the yeast that makes our knowledge grow. Systems may become intelligent because they have to consider all of the different aspects and dimensions of the human being. We certainly are at a difficult time because we did not expect for Giacomo to be hospitalized, but time is of the essence. I can tell you that a father of a vEDS patient does not go by the hours, years, months, or seasons. So maybe this is a different approach that we take on research, but this is the way that we move in terms of time and to actually fight against this disease. So by way of conclusion, I would like to say that, for instance, when Giacomo had his first crisis in 2021, there was nothing. We asked Dr. Castori to come in intensive care, in the intensive care department, to explain the clinicians and nurses how to deal with Giacomo, because he was the only one who could actually actually give the correct indications. And in these few years, we have gone a long way, and it was unimaginable at the time. But having said that, we still are faced up with this pressing need. That is, our take on time is totally different. The perception of time varies depending on individuals and situations. That this is a psychological consideration well known to all of us. And as far as we are concerned, everyone that allows us to get closer to the situation of our son and our grandson is well received. And also on behalf of sons and daughters, we wish to thank you. I feel very moved, very emotional. So the third element, aside from the perception of time, is emotions that drive us forward. Thank you. So the fundamental element that is the contribution of patients association is a fact. Patients do cooperate and support research. They provide samples, and this will be even more so in the near future. Obviously, time is of the essence. It's not that we want to press, but we must realize how important time is in this field. I am familiar with this. I feel this pressure. I do exert it every day in San Giovanni Rotondo. When the background noise, well, okay, we can do it tomorrow. Or, well, we go step by step, little by little. This is something that I hear being repeated too many times. And I reply, no, if I am committed to achieving something, I want to the commitment to start from the basis. It has to be a complete involvement. So our role, aside from what we have been saying, it's also a role that promotes innovation. We know that we have emotions that come into play, but we have to regulate our emotions. We must be rational. And it's like when in some situations we have to say no, because that no will be transformed into a long-lasting yes.
My colleagues and I tend to be cautious, but we tend to be cautious because we're doctors and we know how the human psyche works. We know that we treasure people. I know this could be out of fashion nowadays. Yeah, but this is a sort of this is not patronizing. This is good patronizing. This is a healthy patronizing attitude. So today has been a glorious day. We were discussing over lunch and we are finding new avenues. We are exploring a new future. We are navigating challenges nowadays. I was able to meet new friends. I connected some friends of mine between themselves, and we were all joined together around a table. We have established a new dialogue, and this can only be the beginning. This can only be a beginning
di novità, di innovazione.
of a success story of innovation.
Anche di tipo non soltanto prettamente tecnico e
But
tecnologico.
I'm not talking
Io
about
penso che questa debba essere anche, diciamo, l'arena
technology
in cui
and
proponiamo
technical
delle
aspects.
di tipo
This
organizzativo. E anche
must be the beginning of a new
dell'innovazione
organization.
rispetto alla relazione medico-paziente.
And
Io ci intravedo delle cose
this
di
must
cui
be a new
non faccio
beginning
parlare
in the
adesso, però,
patient-doctor
non
relationship.
è soltanto un gruppo di ricercatori
I
clinici,
can see some new
siamo
hints
un gruppo di
because we are a bunch
individui
of individuals,
ecco, quello
of
che voglio dire è che quello che
special
noto è che siamo
people.
tutti un po'
We are
particolari
all a bit peculiar
rispetto ad
compared
altri contesti che io conosco,
to other
anche
areas
intorno alle
which I know.
francamente.
And I know many areas around vascular
Grande
EDS.
entusiasmo. So che non
So
sono
a
un
lot of
amministratore
excitement. I know that I'm not very good at
però voglio
exciting people, but I've been trying
il mio
to
grazie a tutti.
launch a call for action. Thank you. I've been trying to be as passionate as I can. I actually forgot to thank Professor Fabio Bertoldo, our host. Let me thank the Tor Vergata Hospital, the organizers of this symposium, Alessandro Signano and his team, because they've been essential in organizing this day and gather us all together again. Yeah, I'd like to think I've got the honor and the privilege of opening this meeting up and drawing it to a close. This meeting has exceeded all expectations. As Marco was saying, all people which have been involved are special people, not only researchers, doctors, patients, but there's something more here. So, Piero, rest assured, we are cautious because years will go by fast, but researchers are taking steps forward. We are fully committed. We understood that we cannot be on our own. We must build strong networks. Nobody will stop us, and this must be clear. So 3 minutes to thank a few people. Let me start from our host, the Tor Vergata Hospital, which have hosted us today. 4C Lab, Dr. Sirignano with Danilo, Tiberio, and Stefano and Simone, who have been helping us and all the ancillary personnel. Marco, Pietro, the organizing committee. Needless to say, the speakers, outstanding speakers. We read their bios and we're lucky enough to have them with us today. Elegant, easy presentation speakers. Our audience has been quite mixed. And then our moderators, Mr. Gaudenzi, including Mr. Gaudenzi. When you have strong partners like RAI and Telethon, then you can go anywhere. As a politician, we say we feel reassured in making promises. And then let me thank all our friends of the aorta and all the heart. We have other associations, other illnesses, closely related illnesses, which will help achieve our vEDS aims. vEDS is very rare. Other illnesses will help us find a treatment for vEDS. Let me thank Clotilde, Franca, Valentina, Anna, which are part of the Marfan Syndrome Association. We have the ConGiacomo Association, Marfan, and another association. What does it mean? They work together that will help us achieve our aims more quickly. Let me thank our friends from Bergamo. Let me thank all of you, and we're going to start working from today. We want to improve the quality of life of our patients, and let's think about the future, and let's try and give our patients a life expectancy which could be as close as possible similar to the one of the general public. So you're gonna meet online to take a further step, and then please put down your name, put your just think about those who are fighting against this syndrome, and we'll all be stronger together. Thank you.